Okay. So in our project, we were asked to consider the underlying economics of the war on drugs that the U.S. government has been waging for about 35 or so years, and to set the stage for that, the first thing we're going to do is to give you some data about the actual costs and benefits of this situation, and eventually want to reach to come up with a rough estimate of the supply and demand functions for drugs, which will then allow us to estimate the impact of alternative situations, such as legalizing drugs when the government is a monopoly, or just letting free competition take over this market. So I'm going to start by listing the costs and benefits of the current situation where drugs are illegal and the government has a market. So under the benefits, they're not that many, we just listed one. We thought of consumer surplus of consuming this good as a benefit of this market. And we don't care much about the consumer surplus. Then under the costs, we have a whole list of them. So divided as follows. So we first thought about enforcement. And I'm writing these down because I'm going to add values to this course. Enforcement / prevention policies of the government. But also prison costs, which we separate because we have different data for that. And then there is other costs such as accrued medical costs and social security costs due to the impact that the use of drugs has on health. And then we have other types of costs such as violence by people who are involved in the marketing of third parties. So people who are not participating in the market. And then violence within the market. So these were our the costs we thought about. These top four kinds of costs are all externalities. And we assume that the balance within the market is part of the trade and that the prices of the drugs actually reflect those costs. Whereas those are actually costs imposed on the rest of society because of this way. So the first thing we want to do is to actually get an idea of what the relative values of these things are. And then eventually write a very rough estimate of the supply and curve. So we got from the we got rough estimates for this from the web. Basically, we're focusing on cocaine and the market for cocaine. And what we did was most data we have are for the entire war on drugs. We know the relative value of cocaine within that market, which we estimate by the value of the seizures of cocaine relative to the drugs. And a very rough estimate of the corresponding costs is just to take the same share of the cost. Though that's an overestimation because, of course, a lot of fixed costs in having the war on drugs because cocaine and other drugs are to a large extent, some extent. But so what we found, come up with, was that this would be about $6 billion a year, and also it's been constant for the last. This data is from 2003, I think, but it's been constant for the past year.
So you separated this out between the cost of the war and the cost that would exist absent prohibition.
Of this particular.
Yeah, I mean some of those are prohibition costs, and some of those are
yes
external costs of the drug.
Right, this would be external cost of the drug, it's not prohibition.
And what about the violence?
For violence, so this part of violence is for the prohibition. Violence on third parties is just like negative effects of the drug. People, for instance, the human capital is maybe reduced that has an effect on third parties.
Oh, okay. So that's separate from like the guy who gets shot in some gang war.
some
innocent bystander gets shot.
Actually, that's true. We should probably divide it into those two costs. But the reason we're not, I'll talk more about this when I get it. The person's cost, similarly, we estimate to be $2 billion a year. The medical cost is interesting. Just like in the cigarette smoking case, there are accrued medical costs while people are alive, but there might be less Social Security costs because the life expectancy actually goes down. This is kind of a silly calculation, but we just assume that these things cancel out because that's the case for, seems to be reasonably the case for cigarette smoking. So this will not take this into account. Although this is the kind of, if there is a cost, this is the kind of cost which escalates with quantity, so the size of the market, whereas this is not clear how much they grow. So this would be an important correction.
Not that it matters, but how did you get the prison costs to be so
assume that cocaine was a third of the share.
Yeah.
of drug-related?
Drug-related.
Drug-related
What are the
abuses.
real numbers?
Probably the real numbers are like 90, 80% or something. I mean,
Are-
cocaine's everything. Like nobody's going to prison for marijuana.
No, but most people in prison are dealers. So marijuana dealers go to prison too.
Not very often. They just don't. I think if you look at cocaine, it's probably 70, 80%. Well, I think you're probably, like if I had to think about the prison, like what prison population is there because of cocaine, it must be like 500,000 people or something. Times like 20,000. I would just guess it's got to be 10 million would be my first order guess.
Well,
that'd be more than the entire value that we got from
The entire value is $6 billion for
for
all the
2004.
drug-related prisoners. That's the number we looked up.
For 2004, so it might have gone up even. But even if this goes up, it will not
Yeah, it doesn't really matter.
It will not affect the other results. But it's something between 2 and 5, maybe. Actually, this is the kind of number which we can accurately estimate. So the others are. All right. So then the finance and third parties. There's. I'm just going to consider the cost that you mentioned. The fact that some random person is walking into the shop, and the way we estimate the probability is something like, we first of all have for each person that gets shot, there is a cost of society, which will usually value at the statistical value of life, which is $5 million. So we take $5 million. And then the likelihood that the person does get shot is something which is proportional to the number of dealers, or users, let's say. And then the probability that each user actually kills somebody. So these numbers would have to be, this thing would have to be of the order of 1,000 to get into this order of magnitude. So the probability that, the overall probability that users kill people, for the moment we're not going to consider it as a cost of reason. And the inter-gang violence, this is not an externality, that this is what we call an internality. All right? Now, to compare these two, we have to have an idea of consumer surplus, which is why we're going to write out the supply-demand curve. And I have to hurry up. All right, sorry. All right, so basically, we have to compute the supply-demand curve. We get a price and quantity data point that we have now, and we compute the, we have an estimate the externalities, the elasticities of demand and elasticity of supply. We estimate those, and from those we assume, basically the strategy is to assume that there's a linear demand curve and linear supply curve, and from these two, from the basically data point and the slopes, you can get the corresponding graph, which looks something like this. This is the demand curve, this is the supply curve, and this is our data point, and then we estimate the consumer surplus here. And from our calculations, this consumer surplus goes up to $30 billion a year, which is quite large, and it's larger than the costs we estimated. And so what this means is that, from this very simple estimation, it looks like a world with cocaine is better off than a world without cocaine. Of course, we assume that consumption of cocaine is rational, or it's not. jurisdiction.
So we're assuming here that there's no other, there's really, basically this model has almost no motivation for trying to restrict the market.
No, but the market can become better. I mean,
Right.
if
There would be
we-
no, there's almost no justification for having a war on drugs in the first place in this view of the world, right? Because these medical costs are zero and the violence on third parties is some second order.
Yes.
thing.
So this is but you know, it can better.
It's not legalized cocaine in this world. No taxes, no monopolies, legalized.
Well, we're now going to consider what's the effect of legalizing.
Thanks. So I'm going to try to go from a world of the illegal market for cocaine, flesh out what happens when we legalize it, what effect that has also on the black market. We're going to do that in like 4 steps, and it's all based on these estimates that we came up with. So let me draw first. Step 1 is just going. It's just the illegal market, how it looks like. I'm going to also assume that, or we're assuming that the elasticities of demand and supply are held fixed throughout. Okay, let's just make it simple. Just look at comparative statics. Supply and demand estimates that we found are roughly quantity thousands of kilograms, 300,000 kilograms. The price is about $100,000 per kilogram. That's what we came up with the illegal market. If we go to step 2, we say let's legalize. We're going to assume one more thing here that Tatiana's maybe going to mention. We're going to relax that assumption that no user externalities. All the externalities that within the supply. This is going to be the same. Supply curve is going to shift outward. You don't have now the cost on the supply. They'll lower their cost for everyone. And another thing is we're going to have people substituting also from the illegal market of cocaine. Now cocaine is legalized, so maybe move into that. And also just people who didn't consume cocaine before, now because it's legal, here, so the demand curve is also going to shift outward.
But isn't that violence within the market going to go away too?
Yeah.
Okay.
But this is the legal market. So what we're assuming is that the supply curve shifts down because you don't have to worry about smuggling it. You don't have to worry about hiding from law enforcement. So for the government, the supply curve is shifted down.
Right. We draw it a little bit more realistically.
Can you go back to your 30 billion consumer surplus number?
Yep.
So I think there are about 1.4 million active cocaine users.
Okay.
So if I'm doing the math right, so you're saying that each of them is willing to pay like $20,000 a year, is getting $20,000, on average is getting $20,000 a year in consumer surplus?
So this comes from assuming that demand is inelastic with an elasticity of minus 0.5, and then using the price and quantity of the equilibrium price and quantity on the market to compute the implied consumer surplus from a linear demand curve.
So your spending right now is about 30 billion?
That's the total revenue on the market.
It's
but
about 30. So you're assuming consumer surplus is roughly equal to spending.
Yeah. So that's just the way the numbers are.
You're just assuming they're getting $1 worth of surplus for every dollar they spend.
No, that's not how we computed
It's
it.
about one. No, actually, we can compute
Yeah.
the surplus and the
No, I'm just saying that it comes down to saying they're getting about $1 of surplus for every dollar they spend. I think that's what they're saying.
it's a bit less than that.
I wonder about that. I mean, who knows about these different numbers, but coming at it from the way I came at it, it's hard to believe if there's only 1.4 million. It's just hard for you to believe that the typical cocaine user is spending $20-something thousand, I mean, a year on cocaine.
Some people know, but yeah, some people it's not it's a very skewed curve. So
Yeah, it could be, but there are a lot of, I mean, because you think of the typical crack addict who's making up maybe 60% of these numbers, I would say. Because I'd say over half of cocaine production and volume is coming through crack. they don't have $20,000. I mean, they do spend everything they have on crack, but I don't think they have $20,000.
Well,
It's
you
just
could have
another
the-
way.
It's a total
But I mean,
spending
but the
number
total
that seems to
spending
be
is
off.
30.
Right,
That's
probably
the
not the
question.
surplus per dollar of
I think
spending.
that's right. So that's it. So
But that's not how we derived the number, though. They just came out to be very similar than the total
Right.
revenue.
No, all I'm saying is when you derive, it's a good thing to think about. So you derive the number one way, and then there's a totally different way to derive a number. I think it's good to derive these numbers in all different ways and say, okay, like the way Kevin thought about it makes kind of sense. Like for every dollar I spend, I would have been willing to spend $2. Or I got $2 for the value for the thing. That doesn't.
That's a sanity check on your number. If you say the guy's, spending $1 and he's getting 2 cents in surplus, you say, boy, that would really mean
Right.
the guy's getting no surplus. On the other hand, if you said he's spending $200 of surplus for every dollar he's spending, it's like water.
Right. You flip it around and you say, okay, could these guys be spending, but maybe they could be spending 20,000. But
Yeah.
then you start thinking, well, it's just a way of saying all these numbers in the drug area are made up. Like, every single one of them is made up. And so sometimes people just made mistakes along the way. It's helpful to try and figure out which number might have been made up. Okay, so I didn't want to do that, but just to throw the base up.
Okay, so since we're government and we're thinking about acting as a monopolist, but we're looking at what our objective is to find the socially optimal allocation. So it's not like marginal revenue, not the point of where marginal revenue equals marginal cost, but the point where it kind of reflects the outcome of a competitive market. So this was the previous allocation under the illegal market. This would probably be, at least under what we think is the allocation that we want to get to that would be socially optimal. And using the estimates that we have, it would not be good. We count that the quantity supplied here is 366,000 kilograms. The price is actually higher. It's about $116,000 per kilogram of cocaine.
And how are you thinking about the supply curve here? Because I'm surprised your supply curve didn't. I mean,
Yeah, I'm holding elasticity sticks with this whole analysis for now. I agree that the elasticity could now be more
The
elastic.
size of the ship down. It seems like the size of the ship down is
I would think that if you made the government, except the government might be inefficient, if you made the government the monopoly supplier of cocaine, it would be like sugar or salt or flour or something like that, right? And cocaine, I think, would be free.
It depends if you can grow it in the U.S. or not.
If we're still importing it.
All the
Cocaine, I mean, I think if you do actual cost of what it takes to grow cocaine, it's like a weed factory. It's like marijuana. You can get, virtually, it should be as cheap as like coffee or sugar. I think you basically make the best approximation is make the supply curve basically flat at like 0.
That's what the government produces it domestically,
What's that?
rather than importing it.
No, import it. But it's what the cost. I mean, it's if we weren't like spraying Agent Orange on all the guys who are trying to grow it in Colombia, they could grow as much as we wanted for next to nothing.
Which is similar to the supply curve for the.
Yeah, I mean, I think the marginal cost. I think the marginal cost of producing cocaine would be something like instead of
Saying
it
it might
would
be
be
something more like
1/50th
this.
or 1/20th what it is now, and it would be totally flat.
Yeah, so again, quantity is going to increase unambiguously, so the question is whether the new price is going to be above or below the price that we found in the illegal market. So either way, it won't change, at least for now, it won't change anything, and I'll show you, I'll just show you that it won't matter. It just matters if like we crank up law enforcement or we actually kind of can lower the level of expenditures and appropriations to law enforcement. So the elasticity of supply won't matter, at least in this case. So moving to step 3, and another thing that we can see, at least in this graph, no matter what the supply curve is also the effect on quantity of spending $8 billion in law enforcement. If there wouldn't be any law enforcement, so let's just take this. We remove from the black market the law enforcement, and the supply curve will shift to the right because the costs went down. Then you could find new kind of price and quantity demanded. And well, according to the estimates, if you believe them or not, actually the difference in quantity supplied in this market is very small. Law enforcement is not that kind of normative speaking, it's not that effective.
How much did you move the supply curve down in that analysis? Like, what did you do to decide how far to shift it?
He would just use the cost of,
We use 30 million to buy the enforcement infringements cost divided by quantity.
You assume that, like, you assume what it costs us to enforce is what it costs the suppliers to have it enforced on them?
We assume that for every dollar spending, you're imposing an extra dollar cost
Right.
on the suppliers. So we added up the law enforcement costs and divided by 300 tons to get the price per ton.
What about
and
the
we assumed that
violence?
was the shift.
What did you do with the violence and stuff like that?
Violence within the
Oh,
market.
well, we didn't count violence. We were just trying to derive like how much does the government spending impose an extra cost, internal cost on the black market? By how much does it shift their
But don't you
supply
think
curve?
it would become less violent if the government stopped enforcing the law?
Yeah, definitely.
Starbucks guys don't go shoot the pizza coffee guys.
Yeah. So I think that's what Yoshi will talk about also,
Yeah.
like what happens to the
Oh,
black
the
market.
post
just in sake of time, I'm going
Post
to
office, that's government. The post office is a government monopoly. That doesn't go down.
You guys have kind of run over, so you guys got a little bit.
Yeah, that's what I'm trying to. Okay, so let's go back. So let's say now we legalize, we're at with this allocation, but we're still stuck with at least if the case is that the price is higher, then we still have a problem with the illegal market because they can still supply it at $100. How do we deal with that? Well, let's just assume that a person is indifferent. If the price in the illegal market or the legal market is $116, they're going to go to the legal market.
Oh, wait a minute. But you have to ask why that supply curve is upward sloping, because if that supply curve is upward sloping because you're pushing up the price of inputs, that's going to raise their costs too. And if these guys have an advantage, they're going to continue to have an advantage. You're sort of acting as if the illegal guys are getting their cocaine from some other place, then these guys are getting their cocaine,
That's what we
Right.
which I'm not sure why.
You mean why we shifted the supply curve?
I didn't join at the illegal market yet. Okay? So your comment
You're
is
saying they
actually
can still supply at 100. There's no reason they can still supply at 100.
Okay, so let me, I didn't even draw anything there. All I'm saying is that if someone could get a kilo of cocaine in the legal market for 116 or in the illegal market, they'll go to the legal market. That's all I'm saying. So
That's why the demand curve shifted out.
right. So one thing that's going to happen in the legal market is that the macro is going to shift to the left now. You're going to have people substituting in, plus other people that didn't consume cocaine before now consume. But either way, now if I show the illegal market, we don't want to say that this point here is where the demand curve is going to intersect the price axis is going to be 116. The quantity demanded here is 0. So this is kind of an assumption. If I keep elasticities fixed, then it's like I could get a lie out of this. The supply curve, so either have the old supply curve and just kind of draw it here, or I move it whatever I want. But I could kind of, in terms of how the government could know if they could finance. According to this, they're going to have to increase law enforcement, right? I'm going to want the supply curve to shift upward here. So actually, it won't make sense for anyone to enter the black market because no one's going to buy them. So I could do that using a tool of law enforcement. In this case, it's cranking it up. But if we take Steve's case, where actually the supply curve is low and the price goes down, then
Because the movement along the legal supply curve is going to cause their cost curve to shift. If they're competing
Right,
for
so the
inputs.
monopolists can compete on the demand and on the supply. For the moment, we're just considering the competition on the demand.
Okay.
If you consider competition on the supply, that means you have to go buy from equinors and directors and stuff.
Yeah.
The question is, why is the supply upward sloping? If the supply is upward sloping because of common inputs, then
Yes.
The other thing is just, right, we're not in a monopoly world, right? Because we're still on the supply curve here. We're pricing at marginal cost now.
Yes.
There's no monopoly yet.
Right.
No, we're also
So the
not.
legal market's pricing at marginal cost. I think all Kevin's saying is just that the marginal cost is the same between the two, then there's no demand for the illegal market, basically.
if they have an
no
advantage
scope
equal
for
to that
illegal
vertical
market.
difference,
Right.
the illegal market's shut out.
Right, exactly. Every unit strictly prefers to be bought in the legal market. In that case, because consumers
Holding
prefer it and the
price
costs are
range.
the same. Right.
No, but you could still have the black market supplying at a lower cost, lower
In this
quantity.
case, it doesn't much about.
What comparative
Oh,
advantage does
if
the
the
black
marginal
market
costs
have?
are-
There's no tax, there's no monopoly.
That's like a
Black
Walmart
market
would
has
have
no
a black
comparative
market in
advantage.
coffee or
Yeah.
something like that. I mean, there's just no.
Yeah,
black
there's no
market.
guys out selling
Yeah,
the
but if you
black
assume
market
increasing
Starbucks
marginal
competition.
costs, though, there will still be a black market.
Yeah, if you have a monopoly or a tax,
Yeah.
you can have.
If you had a monopoly and you raise price above marginal cost, then you're off the supply curve. So then, for sure, there's a scope. There's scope for entry. For sure.
So basically,
Okay, so yeah, sorry that we're over, I'm gonna
No,
talk.
we're gonna interrupt.
Yeah, what's our fault?
Okay, so just to talk about, yeah, so as you correctly noticed, we assumed that there was no externality, no big externality on violence on third parties and cocaine users. I mean, but obviously to make the tax question interesting, we're gonna just scrap that and assume there is some user externality perhaps of becoming addicted. People underestimate the probability of becoming addicted, and that's not the choice they would have made if they were fully informed. So we can redraw the supply curve to be flatter, and this is the demand curve, and let's say that this is the fully informed demand curve. So now in order to set the tax, the government will, set this to be the size of the tax, and this to be the price. And this is obviously going to be higher than the price without the externality. And if you want to talk about the monopoly, so for the monopoly case, we assume that even though the government had a monopoly, it wasn't acting as a monopolist because we assumed a benevolent government was maximizing consumer surplus. So the main difference between having the tax and being the monopoly supplier in this case, so here you'd have the same price, is what happens to the producer surplus and the consumer surplus. So here
You assume that the government maximized total surplus.
Yes, sorry, total surplus. So it would price.
It would be the same. It really will be the same thing.
It will be the same. So really,
the supply curve is going to be fully, going to be infinitely elastic in the case where this thing is legal.
Right. Well, that would also be not that interesting because then you really wouldn't have to worry that much about the black market. So at least, right, which could be the case. So this is the government revenue here, and this is producer surplus, and this whole thing would be the government revenue. So the way that we went with this is here, like if you think about the supply curve of the illegal market as reflecting some opportunity cost, this is the price that the government charges. Here the opportunity cost of being on the black market is higher because you could be in the legal market selling cocaine legally and getting like part of this producer surplus, and here your opportunity cost is lower. So having and this is still PG. So having the government having the government set a tax could be better for keeping the black market smaller because it's going to impose. Sorry, I didn't draw this very distinctively. Because it's going to impose an opportunity cost on the people in the black market. And that's another way to reduce violence. And the question of whether you want to be a monopolist or regulate the market, it depends on what you believe about how much it costs. Whether, if it's dollar for dollar to prevent like a dollar's worth of violence, then it doesn't matter. But if it's more costly, it's possibly more costly to have law enforcement because it's hard to find those guys. If you just allow them to go to the legal cocaine business, they'll come to you. So it's potentially less costly for the government as a whole, if you believe there's violence, to set a tax and to raise the opportunity cost of these guys and have them come into the legal market. And you could also potentially have some complementarities with other drugs because there's some fixed costs in law enforcement. So the implications of all this is that you might also want to legalize some other drugs too. And we tried to think of something better than. It's hard to think of something better than like monopoly versus regulated market versus illegal, because everything is kind of everything else is a side policy, right? Either drugs are legal or they're not, and if they're legal, either you have some regulated market or the government is a sole supplier. You can think of, like cap and trade, which would be really weird, or some kind of licensing, but we couldn't really think of anything that would seem better. You could have a lot of side policies if you believe that there's some user externality. You could spend the money on rehabilitation, on education, so that people know what the real costs and benefits are.
We did come up with like substitutes. So our policy could reduce punishment on substitute drugs. So that would like push people out to another market. That will reduce consumption of cocaine. Or like substitute.
Yeah. Like
or reduce law enforcement on substitute drugs, which have the same effect essentially.
Legalize marijuana so that fewer people do cocaine.
I don't know if that's a good substitute.
Yeah. Well, yeah. Whatever is a yeah.
All right. Why don't we get our next group up there, and then we'll go from there. While they're setting up, one thing you might want to think about is, if in fact there's a reason those supply curves slope up, is there's some assets that have greater utility in the drug business than they do elsewhere. Well, you kind of got those assets kind of now, like double the number of those assets. You have the government using the assets, and then you're still assuming they're available in the private sector. So you've got to kind of take a stand as whether the government uses those assets or they don't use those assets. You kind of like, because when you drew the government's cost curve kind of the same as the private sector cost curve, and then assume there was still this private sector cost curve out there, it's like you created a whole, like you doubled the number of these inframarginal assets. So there's kind of adding up problem.
Yes.
Yeah, you got to be a little careful.
So, good morning. We will also talk about war on drugs. And so first, let's talk about some facts that we found about the drug market. So basically, the number of cocaine users and the amount consumed are basically flat from the 90s to 2000. And according to government data, there are approximately 6 million cocaine users. Half of them are chronic users, half of them are occasional users. And approximately 0.3 million people are annually arrested for possession of cocaine. And the punishment of possession of small amount of cocaine is roughly range from fines or 3 years in jail. And the market size of cocaine is estimated to be 36 billion in expenditure, and 30 billion out of that are from chronic users and 6 billion from occasional users. And the total amount consumed per year of cocaine is roughly 259 million grams, and per gram rental price is approximately $100 to $200, just 140 here. And so to bring about the problem about this war on drugs, we want to focus on the cost of this cocaine market. So we divide the cost of cocaine market into two types. The first type is the cost from the use of cocaine, and the second type is the cost from the prohibition of cocaine. So this line is about the cost of using cocaine, and it can be divided into three groups. So it's healthcare costs, approximately 1.6 billion, productivity loss, 38.2 billion, and public costs, 8.3 billion. So you can see the biggest number here is the productivity loss, which is mainly due to the opportunity cost of the premature death and illness and hospitalization. So this is the cost that when we put somebody in hospital, that guy cannot work. So that is the loss to that individual. And the items in red are those items that we think the consumer most likely will at least partially internalize. So the reason that, so they will care about the money that they cannot earn in hospital, but they will not think about the money that cost for the healthcare service. Those probably will be paid by the government or the insurance company. Okay,
So how do you want to cost those out socially? If the government pays the money, like if the government paid $1 billion because people use drugs, how do you want to cost that out socially?
So it's
The
a
social cost of that
Yeah.
money.
That money is a social cost.
The whole, all of it?
So you might want to have dead weight loss and raising that expenditure. Multiply it by
Yeah. And that number compared to these numbers are really tiny, so we want to focus on that. So next is the cost of prohibition. It can be divided into 5 items. Again, the main one is the productivity loss.
Go back to that. It's premature death. Is that
It's the statistical value of life, the value of their life that month they die.
but this is deaths from use,
Yes.
not deaths from violence and stuff.
Yeah, from consuming. Yeah. So the cause of prohibition. The first one is productivity loss due to incarceration. So that is the big number, 28.5 billion, and then others are smaller. The private legal cost is 0.5 billion, and the state, federal, local correction cost is approximately 10.9 billion, and the legal adjudication cost. So that is the money that the government pays for the legal cost. That is 4 billion, and the money that government has to pay to reduce the supply of cocaine is roughly 4.4 billion right now. So these are numbers that we found. And
so if you just add up those numbers, the ones that were not in red, that were on the use page, the externalities of use add up to about 11.7 billion, and the externalities of prohibition add up to 19.4 billion. If you look at only the items that were in red, the things we think are at least partially internalized due to use, is 36 billion. So this is a huge number because that's the productivity losses that people take into account when they do drugs if they're rational. And if they're partly myopic, so they only internalize about 80%, they'd be internalizing about 28.8 billion. Then you can look at the internalized cost due to prohibition. That's about 28 billion, and most of that comes from the opportunity cost of being incarcerated. And if they were myopic, then they might internalize only 80% of it, and that would leave it about 22.8 billion. So here,
Sorry, can you explain again how you think about myopia visa? I thought these costs of prohibition, you guys so far have just counted out money the government, real resources that the government spent in prohibition. No, it was something else.
So no, the government and people. So there was, yeah, there was the ones in red. How do I go back here? The ones in red are things that people have to, the private costs.
So in this case, the costs go up then if people don't fully optimize against those, I guess, right? You're saying because those costs actually are incurred. Okay.
Yeah, those costs are definitely incurred, and people are not.
Somehow we want to increase the number, not decrease the number because of myopia, right? It makes it worse.
Right. We want to increase the social number.
Yeah.
Yeah. If they're not internalizing it.
They're not optimizing against it, right?
Right.
So what are we trying to calculate the externalities?
We're going to calculate that because we're going to think about optimal taxes and the optimal monopoly price, not from the standpoint of profit maximization, but
But would these prohibition costs?
But yeah, that one will disappear.
No, the prohibition cost will not be there. Yeah.
Okay.
But we want to talk about the net gain of legalizing, and so that's why we're talking about the prohibition cost. Okay. So then if we think about the optimal tax, here we're thinking that externalities are on a per unit basis. They come from using more, all of them scale up with usage. And then we're thinking about an optimal tax as either internalizing all the externalities of use, which is the 11.7 billion, or internalizing all the externalities of use and the ones that remaining 20% that's not internalized by people that should be internalized, and that would lead up to 18.9 billion. And so if you just take that and take the quantities currently sold in the market, that 259 kilograms, then you get a tax per gram of $46 to $74.
That's you just added back the internalities from use, right? Not from this.
From use, not prohibition, right? Exactly. And so here we're thinking about. I should say there's a couple assumptions that we're making before we get into this. One is that there's a constant marginal. So we're assuming flat supply curves everywhere. So the constant marginal cost that to user or to producers right now, and this constant markup they're giving because of enforcement. So right now in the illegal market, where there's a flat supply curve. And what we're thinking now is that the government, when they step in, they're also going to want a flat supply curve because they're just going to put a per unit tax that's going or above the marginal cost or a per unit markup that's basically going to internalize all the externalities that are in the market. And so if we think about it that way, we think about the fact that the government doesn't want the black market to compete with them. It's the maximum price they're going to be able to charge while still deterring the black market. And to calculate the maximum price, we're going to think about coming up with a maximum price for cocaine and coming up with a maximum price for crack. And for cocaine, the observed price is around $140, but there's also this implicit price, and the implicit price comes from the fact that you don't really get things that are very pure right now on the market. Something like 60%, the average purity is about 60% of the market right now, and about 6% of cocaine sold now is just pure baking soda. And if you take 6% times the price, that's about 7.2. So that's saying that for purity, people should be or are paying an extra 7.2. And then for the expected value of incarceration, we basically said that there's a 0.1% chance of being incarcerated. We calculate that from the numbers of users and the numbers of incarcerations. And we said there's an opportunity cost of being incarcerated for people who do cocaine of $60,000 a year and people who do crack $30,000 a year. So we come up with these maximum prices that we can be pretty confident the government can charge without having to compete with the black market. And there's an important thing that we're leaving out here is that there's probably additional safety value from having the increased purity in the sense that, you know, it could be laced with anything, more dangerous drugs, more dangerous chemicals that people could be smoking or sniffing or whatever. And we put an upper bound that people should be willing to pay for that is $100 a gram. We think that that's probably too high, but that's probably an okay upper bound.
So this is a graphical representation of what we're talking about. So we have the demand curve, we're talking about everything long run here, so this is a long run demand. And let's see, so let's start first with the supply, the current supply, we call it S criminal, and that's the criminal market. So what is S deregulated now? Okay, so if cocaine was to be deregulated, then this is what we think the private supply. Why is it lower? Well, because now the consumers bear some costs that the suppliers are allowed to go to the consumers. Why? How do we find the number 15? That's like the price that we found is like the price that now prevails for using cocaine for other uses, like medical, so which is a legal way to use cocaine. So that's what we assume the price. And so now the Pmax is the price we were talking about before, is the maximum price that the government can charge. Above that price, the black market will pop up again and will crowd out the government, the economy service. And so the whole problem is where is the social supply? So where is the benefit from society? If it can be lower, in that case we have to lower the prices. To up is the current price. Okay, so if it's lower than the current supply, then we have to lower the price. Higher, we have to increase the price. But it might well be about the Pmax. In that case, the constraint is binding, and we should like set P equal to Pmax. Okay? You want to take this?
And so just to reiterate what he said, basically, the lower cost for the supply deregulated is basically what we are taking as the marginal price, marginal cost of cocaine. And that's basically, again, because it's the legalized price right now, so the legal market for medical purposes. Of course, that could be marked up and it might be actually lower, but that only sort of further boosts the results that we're going to find. And then, so the optimal monopoly price is just going to be a markup over this that I previously called the optimal tax, and it's going to be $114 to $142, and for crack it's $9.5 to $12. So first thing to notice is that this is well below the upper bound that we saw before. So basically, the government will be able to charge this optimal price. The other thing to notice is about the price that's currently charged right now. But quantity is going to go up because the implicit price currently charged right now is actually higher.
Per unit of real cocaine as opposed to per unit baking soda or whatever.
Exactly. So, and we had a very conservative estimate of the current price because, like I said, about 60% is the average per unit. Yeah, we didn't include the health benefits. So basically, drug use would go up. And so what we do is we take a demand elasticity of -0.7 taken from the literature on cigarette use, and we look at the price reduction from the implicit price of $2.15 to somewhere in the middle here at $1.30. And what we see is that there's a 34% increase in drug consumption.
So when we think about the difference between a government monopoly versus imposing a tax, you can basically achieve the same price quantity bundle either way by, we assume, flat supply curve, so the government either sets a tax equal to the difference between marginal cost, or it actually sells for that difference. So the choice between monopoly provision and private provision comes down to more amorphous concerns. The choice between legalization and one of these two alternatives saved us about $50 billion on the prohibition cost, maybe some more from the additional violence costs we didn't quite capture. So when we think about monopoly versus private provisions, there's political economy concerns. We may worry that if we legalize and want to heavily regulate drug use, then we'll create these private firms with an incentive to lobby the government for laxer regulation or lower taxes. If the government is the monopoly provider, we have issues of corruption in the government due to the drugs. We may worry that changing who's providing the drugs may change social norms, but if the government is selling these drugs, it may involve some implicit endorsement effect. The government is probably going to be less efficient in production, but the government may also have more bargaining power with producers, especially internationally, for importing a lot of these drugs. When we talked about myopia, I think there's a big gain to modeling that more carefully. So if we think of the role of decision-making and how addicts become addicted, a lot of the psychological literature suggests that there's cued consumption in the consumption of cocaine. So various familiar surroundings, advertising, etc., can induce these cravings. So private firms are going to want to have an incentive to induce advertising and the production of negative cues that induce cocaine use. The government may not have that same incentive. The government may be able to regulate advertising, but there may be a whole space of cues that private firms could produce that the government can't directly observe. So that may be an advantage to government provisions. Finally, if we've been consuming generally that the market is competitive, if there is price discrimination, if the government monopoly would clearly have market power, private firms may also have market power. Once you become addicted, you're more price inelastic than entering addiction. So a monopoly may do nonlinear pricing. So from the government monopoly perspective, if people are entering due to mistakes, you may want to have high upfront costs, but low marginal costs once you become addicted. And this is the difference between preventing entry into addiction and an insurance motive from taking money from existing addicts. So that may be the optimal price discrimination from the social perspective. However, the private market is going to have the exact opposite incentive. They're going to want to have low upfront costs to induce these mistakes to get people addicted and higher continuing marginal costs. If people are rational, they'll expect that and they'll get compensated for low upfront costs. If people are not fully rational or not fully internalized in the future, this won't occur. Finally, we talked about a bunch of different alternative policies. You might think of waiting periods. If there's transitory mistakes going on, you might think of information, education concerns. You might think of pre-commitment devices. You could sign up for a license. You can sign up, like in current casinos. You can put your name on a banned list for a certain amount of time. Those would be alternative policies. But in general, there's large savings to legalization, and then the monopoly versus government provision, monopoly versus private provision is slightly less important in that decision. Thank you very much. Questions?
Questions, comments? So, two groups agree. This is their about, what do you say, $50 billion savings plus or minus from going to private?
Yeah, so it's over this more than one time the market size or the market value.
Yeah.
Is that your guys' conclusion, or you guys conclude something different?
The first difference in the conclusions is that in their case, in the illegal market is this, there is a result to have the prohibition, and in our case, we do not take into account some of this. So that will also change this.
I'm sorry. One of the big things was that productivity. I think your productivity numbers are crazy.
We got them from a government report on the estimate of such things.
Right, that's what I'm saying. People are making stuff all over, and because we had like 20
which way?
right? So
You mean the cost of producing?
The foregone productivity being locked up was your biggest component.
That shouldn't matter, right? In the sense that like that's what we're assuming people are internalizing. So even if that was not, we're not using that to calculate our numbers.
So that's not part of the 50 billion here.
That's not part of the 50. The 50 billion was.
That includes the
That includes that, yeah. So yeah.
My guess is that's valuing people at like some average wage in the market or something like that, and guys are getting locked up.
But for that piece, isn't all you really need to know just what would be the cost of producing cocaine absent prohibition, and then just take the difference, and then that's your box that you're losing from all of the stuff that the guys have to internalize as a result of.
That's the way I would.
I mean that basically that you have, you have like the market as it is now, let's just deal with this like, you know, this perfectly elastic case. And then when you're going to legalize, you're just going to, and if you do this, then you basically know like the per unit cost that these guys are internalizing. And this is prison and death and, you know, whatever else is all inside this like wedge here.
That's only if you take the effective legal price. That includes the probability of getting imprisoned. So there's if you
no, this is the
The
price.
market price is going to internalize
This is
all
like
the supplier's
this is like
costs.
suppliers.
How about
They're talking about
consumers?
Users.
They're talking
Yeah,
about
suppliers.
you want to have the users.
No, because their number, because your cost, because your total external costs are way larger than the total value of the price times quantity, right? Right, so they got to have a bunch coming from the user side.
About 300,000 people get arrested each year.
You're trying to figure out how much
because,
better
I
the
mean,
product would be.
Not really. Let's say that's $30 billion. And that box, their whole revenue, you say is $36 billion. Let's say the true production costs are 6 of that. So that box is 30. But that doesn't include the cost of the government of putting the guys in prison. You got to add that. You got to add the law enforcement. You got to add the courts. So we got like 30 plus the law enforcement plus the courts plus the cost of the government of putting the guys in prison. That's 40-something billion right there.
And then you want to say the users are going to get in prison. So then you're right. I mean, you need to know basically what the effective price is to them, I guess.
Right.
Another way to think about it is how much better does the product get when you legalize it from the point of view of the buyers. You know, and there's a lot of ways to do that calculation. Like you could say what fraction of the enforcement activity is against users versus dealers and kind of allocate that way. You say, well, it's 30 billion.
80% is against users.
Right.
20%.
So you can take your 30 billion and then line up so you have 80-20 allocated that way.
Well, our effective price we estimated was somewhere around $215. So the marginal cost is like say 70. So that's a $140 markup off of the marginal cost.
Yeah,
The
and
current
what's the price
effective
today?
legal cost. So that would be very
So the
large.
today's marginal cost.
Yeah,
Today's marginal cost.
We discussed productivity loss and whether or not to count that, but we decided it was kind of weird because it's like saying you went on vacation, you know, if it's all internalized, it's like saying you went on vacation, that's a big productivity loss, you know, to the U.S. government. Because presumably you're compensated for your productivity, and, you know, if we assume that markets are competitive and everybody's compensated
But
one-to-one.
we didn't count it when we calculated the optimal prices. We're only counting it as like a savings because there's this loss per incarceration.
But it's not, well, right, but the
The question is
productivity
whether
loss
people
is not really
internalize
a loss
those. The
because...
question is whether people internalize those costs and deciding whether to.
Right, and
Well, no, but
also,
you know,
even if you're not
the dealers or of the
internalizing...
users.
Right, like, because if
Of
I
the
pay...
dealers, you want to count it. There's a ways.
For sure.
Wait, why? Oh,
Because
That's
that
part of
changes
that
policy.
That's part of that box right there.
oh, yeah, no, how much you're spending on
No, how much
enforcement.
their time cost is a
Like-
loss. Those guys could be,
Employed.
you know, it's like if you, let's say you decided you were going to put all the guys at Starbucks in jail, right? Then what would happen?
All of this
Yeah.
stuff here, all of this here is like internalized resources that you're taking away from those guys because it's illegal. At
Yeah.
current quantities.
Right.
I mean,
And that includes their time in jail.
for sure.
Because you're going to double the price of the coffee at Starbucks because the guys not only have to work at Starbucks, they have to go to jail for a while. And so you have to pay them for both. But, you know, they're not producing coffee when they're in jail, so that's a
But they're
deadly
also
loss.
not consuming, right? Like, if everybody's compensated for their productivity and I earn like $100,000 less, I also consume $100,000. So on that, like, does it really matter? But I don't, like, if I were to pay exactly, to get paid exactly my value to society, the fact that I'm not being paid also means that I am not consuming that amount. Like, I can see this.
Yeah, exactly. You internalize it and optimize against it, which is why it's incorporated into the cost of the drug. Exactly. You're right. I mean,
But it's not a necessary production cost. You're making the
we're
drugs
assuming we're going to get
cost
rid of that cost
more
if we make it legal.
than they
Yeah.
should.
Yeah.
So in other words, let's say for every hour you work in Starbucks, you got to spend an hour in jail. So you basically made productivity in Starbucks half of what it was because it takes 2 hours to produce an hour's worth of coffee. And if we got rid of that rule, you could lower the price of coffee in half, and save all those resources.
And if labor were your only input, you could measure how much of that you did by basically, just looking at what happened to the price of coffee. I mean, basically, you'd meter your effect on the marginal cost, including the fact they don't like to be in jail. All that stuff would go in there.
That's what's nice about that approach is you don't have to assume where that cost comes from. If you knew what the cost would be in the but-for world, you just know all that gap is this dead weight loss associated with reduced productivity of using.
Right. Now, what you guys wanted to do, which I've never seen before, is you guys also want to say that the dealers are not fully optimizing. In which case, I think you want to make this rectangle bigger.
Yes.
I mean, that basically they're not fully internalizing the fact that being in jail sucks and whatever when they're making their decisions. So the resources that we're deploying because it's illegal are more costly than you would think based on the price of cocaine. Right? There's an additional dead weight loss. Like you want to magnify that rectangle or something.
Divide that number by 0.8.
Right. Exactly. You want to divide that number by 0.8, not multiply it by 0.8. I think that's going to go up by 20% or something.
You guys are productivity numbers. We looked at the wages. I think they were like regional window. So the way they're being computed, these productivity numbers are like very low wages. Like we're talking about. I don't want to say minimum wage,
but they are looking at possession, so there are less.
The case where you.
But if you don't know the
real
world,
one thing that was the number comes out bigger than 30.
If you don't know the cost,
that comes out bigger than 36 billion. But you know you got too big a number for the internalized cost because the total cost of making the drugs can't be bigger than 36. So that would be one check. What fraction of the cost of drugs is putting guys in prison?
And the order of magnitude for the cost has to be, way lower than what occurred. I mean, most of the cost is the fact that it's illegal. If you looked at it like any other agricultural commodity, it's going to be like way cheaper.
Go to that 28. So let's say the 28 was just on sellers and not users, which is like, by my calculations, the paper really had 90% of the enforcement sellers. So 28. So 90% of 28 billion, you're like 25 billion that's coming just from the product, not from the.
Yeah, you're probably allocating. Yeah, I agree. That number is probably allocating too much to that. Too much of that rectangle is then being allocated to their lost time as opposed to the fact that they're getting shot and all the other stuff.
How many guys are in prison?
3 weeks for cocaine. I don't know, 500,000 on stock.
Yes, that means you're doing $50,000.
Kind of like off an average wage instead of off of.
It's like 50,000.
But you don't know even if you legalize cocaine, you don't know if those specific guys aren't going to go to prison regardless, right? So these type of people are going to prison maybe regardless of the cocaine.
That you've got to be careful with this approach because you're assuming that these costs would go away, but I don't know what we got to assume that they're correct. They're so valuing their time at the social cost of their time. Which if the next best alternative to them is something else that we don't like, then
that's like more in the short run than the long run. In the short run, these guys probably don't have such great alternatives.
Right.
And in fact, there's some evidence.
That's a case where you're right. You would want to take a strip out of that box.
Just impoverishes these dealers who got no.
You want to take a strip out of that box.
My guess is more than a strip. We're definitely like suppliers for sure. They just move into another industry of drugs, get into the same problems. Still need law enforcement.
But we know, like in the U.S. alcohol prohibition, it wasn't like there was a fixed number of gangsters and they just went into alcohol and then went back into something else, right?
Yeah, I don't know what to do that. If it's a good.
There's nothing else that generates anything like $30 billion in revenue, so I don't know what they're going to do.
You guys can start stealing stereos and stuff like that, but that's not going to be. That's no time. All right. One issue that nobody addressed, and just to think about it, these guys impose, to the extent they impose externalities on other people, like on neighborhoods and things like that, like shooting innocent people. Did you guys think about trying to do that?
We did have some of that in there. We had some healthcare costs to victims, and we counted that in the externality to calculate the optimal monopoly price.
Yeah.
Actually, you could do something with, this is hard. It's hard to get a good estimate of this kind of thing, but you could do something with like property values, So like, what happens when a crack house comes into a neighborhood versus leaving? What's the price effect on the surrounding
That's nice because it'll also catch like the fact that people do things to protect themselves and stuff like that. That'll all get capitalized into the prices. So that's what's nice about that approach.
Because if you have to,
Like you could have no realized innocent. So no, you could have a world where no innocent bystanders get shot, but it's still extremely costly because everybody's walking around with a flak jacket, driving around in a bubble car and stuff
no,
like
we're
that.
putting
How do you
bars
think
on the
about
windows and all that kind of stuff.
How do you think about the fact that it becomes so dangerous that nobody gets shot because they just sit in their house?
Well, defensive expenditures are part of the social cost because it's wasted.
Yeah, I mean, how do you think about that economically? I mean, anytime, you can think about it like this, that there's some activity that people want to engage in. And, let's just, so here's the picture. Just think of some supply of elastic. And it's like you're putting a tax on them. The drug dealers are taxing them. So what you measure when you measure how much damage is done to them is you measure this box. But the thing you should be counting is this area here. That's the guys who don't get shot because they don't go out of the house, right? These are the guys who do get shot. These are all the people that. So if you knew kind of how elastic people's activities were, you could kind of blow up this rectangle and say for every, once you know how big this rectangle is, if you know the elasticity, you know how big the triangle is, and you can say, well, there's some discouragement effect with that. And that comes up with like drunk drivers and stuff like that. But that's an easy way to think about the part you're missing, because you're only measuring the people who actually incur the cost as opposed to those who avoid the cost. And so it's really just a matter of adding that triangle back.
If you look at the property value differences, you can get the willingness to pay to be able to consume those activities.
Right. You still got the same problem, right? Because you got this is the number of houses that there are, and this is how much the value is reduced, and all the people who move somewhere else. So
the people who become in for marginal,
somewhere else.
The people who become in for marginal because of this cost don't get.
Well,
exactly.
I mean,
so you catch some of this, but you don't catch.
Yeah,
you catch the fact that like now these houses are going to be fitted with rotating gun turrets on the roof and stuff like that. But you miss the fact that a bunch of people now are not on the margin of living here, so they don't actually get measured in that price. Because they're gone.
Yeah, it's like any time you have a tax. I mean, what you measure as the taxes paid is the box, and what you miss is the taxes avoided. And there's a cost associated with avoidance. So, all right, why don't we?
Should we come back at the scheduled time 9:45? Take a shorter break.
Yeah, let's try to keep close to schedule.
So initial allocation in the market, Q the quantity of output consumed, would be Q0, and then taxation would move this to Q1. So as a triangle, here would be a deadweight loss, and we have this is total consumer creditor surplus. Consumer surplus, 2 is producer surplus, and 3 is the government revenue. So it's a simple possible picture. Although we can add one more risk element such as government waste. So if some of the revenues the government collects are wasted, then some portion red area of this rectangle will be wasted, and it will be part of the deadweight loss in taxation. So we would like to ask a question: if the consumption of outcome create an externality, how would we assess optimal taxation? And we can come up with the following objective function. The welfare. First, total surplus, part of welfare. So it's this 1, 2, consumer producer surplus. And the revenue collected by government. We need to subtract from it dead weight loss. So lambda is some negative number that represents dead weight loss. So the waste of government revenues. But also the taxation can partially correct the externality problem. So there is a less consumption due to taxation. So we need to also subtract the externality. So marginal cost is a marginal external cost of the consumption. And we need to multiply it by the after-tax consumption. So this is, in a sense, still external cost still exists in the market after the tax was applied. So we try to maximize the welfare function using different tax rates. And
can we add one more? That triangle of dead weight loss from the taxation in there?
Yeah, dead weight loss is not, so it's not part of the surplus. I will add it right here. So it's C via the whole potential surplus in the market. And we need to subtract this triangle of dead weight loss from it. So we assume that demand and supply are linear. So dead weight loss is a linear function of tax rate. Some parameters. Also, we have a government waste of government revenues.
Why is it linear?
So the change in quantity is going to be linear in taxes. By two, so it should be a 2 squared.
Yeah, there should be a word 2 squared.
I was going to say, yeah, that's yeah, there it is.
So, okay, this is this, right? It's the surplus in government revenue. And we need to subtract the government waste. So it's this. There you go. And furthermore, we need to subtract the still external damage that comes from consumption. So it's still existing damage from market. So maximizing this function with respect to t, we come up with optimal tax rate. That is a function of lambda, that is government waste parameter. So that's the optimal tax rate. And we can see that if there is no government waste, if lambda is sufficient 0, then optimal tax rate is equal to the marginal external cost. So we're back in a Pigouvian framework. So this parameter sigma presents a change of quantity. Quantity changes with the tax, and it's basically a function of elasticity of supply and demand, and can be
That's pretty cool, right? Because without lambda, like you don't even need to know how elastic demand is to do Pavlovian taxation. I always thought that was kind of neat. You just need to know this cost number, and then you're in business.
Yeah.
The way that the elasticity enters here is because the revenue depends on how little avoidance people do, basically, how much people are willing to bear the tax. Sorry.
Yep.
I got excited. Yeah, Pagoo is pretty cool. You got a few things wrong.
So that's a function of sigma that depends on statistics of supply and demand in the derived. So that was our theoretical presentation, and basically next we'll try to look at the real life costs of external costs that comes from alcohol consumption, and we'll try to come up with a number for marginal external costs, and to see how much government waste can be tolerated so that the externally corrected tax will be still beneficial to the society. So let's look at the costs. We come up with, so there are many different costs that comes with the external cost that comes with the alcohol consumptions, such as domestic violence, birth defects, industrial accidents, and so on. But in this study, we just concentrate on the traffic accidents involving alcohol consumption. So it's maybe an understatement of the external cost, but it's a very good example. So first, we look at the lower bound external costs. It includes
one thing on your theory, and you might make that last one a little easier to interpret.
Mm-hmm.
If you kind of like substitute in for sigma, pull out the p's, and express everything as a fraction of p, right? Because then you get it. That's kind of a nice interpretation in terms of like the tax relative to the price depends on the marginal cost relative to the price and these elasticities. Sort of a nice,
so just put
just put that in there and then divide everything through by p. And you get a nice formula that sort of says the tax as a fraction of the price depends on the externalities, a fraction of the price, plus these two elasticity terms. Sort of the sigma doesn't have any units, so it's hard to know what the heck sigma is. So you can write the formula in a way that all the units just drop out and everything becomes kind of unitless. It's kind of always a nice way to, at least for me, it's always a good way to think about numbers, because then you can sort of, I don't know what sigma should be, right? I mean, sigma's in some units that depend on whether I measure this in pounds or yens or something else.
So just plug in real numbers?
Yeah. And then you just get in terms of the elasticity. So then you get everything.
Yeah, I can do it.
No, you don't have to. I'm just saying. If you're trying to explain to somebody your formula, you just sort of say, look, here's how it looks in kind of unitless space. Anyway.
All right. So by far the main external costs of alcohol consumption and traffic accidents, it's deaths and injuries of parties who didn't consume alcohol and who still were victims of these accidents. So it's non-intoxicated drivers, passengers, and pedestrians. So we assume these costs are external, so intoxicated drivers don't internalize the cost of the crashes with other parts. Yeah.
Is there any sense that those damages vary over time, so you want the tax to only apply Friday and Saturday nights, but not Monday morning?
Yeah, of course, Why? The peak of
because people who buy alcohol Friday and Saturday nights might be more likely to drunk drive than people who buy alcohol Monday morning.
When it's purchased, you mean?
Well, it's an empirical question. If they're buying it at a bar, that might be true, and maybe not an alcohol store, but you can get an idea of
yes, so
margins. Yeah.
this is a least targeted tax, right? There are many ways you can make it more targeted, right? You can target, I don't know, night consumption. You can target, I don't know, consumption, at the bars or at night, like the peak of the accidents is 2 a.m. So this is just the most general tax, and you can fine tune it to the.
So that's in the discussion.
Yeah. Okay. So that's by far the biggest cost. It's life and injuries to the innocent drivers, pedestrians, and passengers. Also, external cost is a total.
Why do the passengers count as external costs?
These are only the passengers.
The other cars, the cars that they hit.
Yeah. So in the lower band, we assume that, and then I guess in the upper band, you can say, well, if there was no efficient bargaining, maybe the passengers and the other cars.
Yeah. So it's passengers that drive so they didn't drive with intoxicated drivers. It's a total hospital cost. Again, we assume that everybody have health insurance. So when they're admitted to hospital, insurance covers the medical costs, and then this cost translated in higher insurance prices for the public.
But no experience rating.
No.
This is hospital costs for the drunk drivers themselves.
No, it's for everybody, because everybody is covered by insurance. So even the drunk drivers, they have insurance, so insurance will pay their medical.
If there was experience rating, you'd have to break them up. And
yeah.
For the other guys, it would be all the costs. And for the drunk drivers, it would be only the non-experience rating.
Yeah, I think that.
Remember, for the guys that they're hitting, it doesn't matter whether they're experience rated or not. If we're assuming they're not bargaining with the driver.
But under your view, that there's no experience rating, it's all that stuff.
Right. That's comparing with the actual bills.
Right.
And we have similar view about property damage. So each agent have a full collision car insurance that will cover damage to his own car and the damage to the other parties, so the post liability damage and collision damage. So all the property damage will be covered by insurance companies and thus by society.
So not experience rated.
But
car insurance does not depend on whether you've had a full-on collision because you were drinking in the past.
I don't know like how many of this will be repeated offense, but if it's like your first time, then of course it will not be.
No, because your future premiums go up. So.
So we're definitely abstracting from that here. So while we're calling this a lower bound, both
I don't know if I call that part of it. I'm not sure that I put that in the lower bound. Right? You could imagine. I don't know. I agree. It's probably not. They probably don't fully internalize it, but.
Going to turn out that.
If I called my insurer tomorrow and said, "Hey, I got in a head-on collision because I was drinking," I think they would raise my hand.
Do we know the property damage by drunk driving or not?
No. So what we do have is we have the total property damage, and then we have these different categories of like deaths, incapacitating injuries, and so on. And we know which parts of those are drunk driving. And so for the lower bound, we actually just average overall, which makes it a little more lower bound for what we, I guess, some sort of an upper bound. We said, well, all the property damage occurs in the categories of deaths and incapacitating injuries, where the drunk accidents are much higher.
Yeah, that's kind of the way you can allocate them by deaths, and that's kind of one way. You can allocate them by injuries, and that's another way. You're kind of assuming that drunk driving accidents are more severe in systems on average. And you can see it in the
Which you can see exactly from death and heavy injuries.
Yeah, so and this costs come up with $18 billion. And the total cost of alcohol, so it's all the price multiplied by all the quantity, is is $9.50.
And where is most of that 18 million coming from?
It's mostly
Mostly loss of life,
yeah,
right?
life
And injury and stuff.
especially life. Yeah, that's the biggest. So then we have a upper bound that includes not only this lower bound, but also we have a intoxicated pedestrians and
That's Kevin's favorite.
passengers of drunk drivers. So we have a loss of life and injuries on these drivers. And the total here is about.
So the drivers now are coming into the. This is like the full internalities case or something where like people don't internalize their effects on themselves.
Yes, people don't.
Right.
People don't.
Both the passengers and the drivers don't care about.
Yeah. So.
The drivers don't count.
Yeah,
the drivers don't count. So this is just the people who get in the car. So this is the closed serum does not operate inside the car.
These are essentially total deaths from drunk driving accidents minus the deaths of the drunk drivers.
Well, why are you counting the pedestrians?
So pedestrians.
These are
the non-cozy.
I guess my thought was sort of, yeah, they do get into more. They do get into more accidents, but I mean, they're destroying not really a cozy immersion. And
I'm talking about the intoxicated pedestrian, the guy who was walking.
They didn't get drunk, but we still got hit by a car because these are all accidents with drunk drivers.
No.
Yes.
These are guys who fell into the street and got ran over.
Oh, but no, it's
a literal random walk case.
So if there's a mistake at the table, then it's wrong. But I mean, we're talking because the table said it's with drunk drivers.
That's not okay. Pedestrians are here, but about the passengers. So this case assume full information. So lower bound case have low full information. So passengers that will be traveling with drunk drivers know in advance the extent of their drunkenness and the dangers that they will be exposed to, so they can efficiently bargain with them about it and come into mutually beneficial conclusion, whether to drive with them or not. So we have 60 billion ounces of pure alcohol consumed, and for lower bound, have marginal cost. Lower bound is.
Maybe we should, since we're going over and they just said that they're going to repeat pretty much the same thing, maybe we should let them continue with the analysis. Is that
you get 30 cents? Is that what it is?
Yeah.
I'll closer you guys to done.
Okay. So and this is
what it is?
This is 69.
69 cents an hour.
Wait, is that for pure ounce of alcohol?
Yeah, pure ounce. And, for price is $1.5 per ounce. So that's our external cost, and in the Piguin framework, tax should be equal to this cost. And then the question is, if there is a government waste, how much government waste can be tolerated so that the Piguin tax is still beneficial. And we found that lambda star is 0.3, so only 3.8% of government waste can be tolerated, so the Piguin tax is still beneficial to society. And we had more important assumption that marginal external cost is equal to the average external cost. So that's our critical, that's a maximum government waste that can be tolerated with Piguin tax.
That's much.
Yeah, it's 3.8%. And So the exercise asked about 20% government waste, and of course then it will not be beneficial to levy any taxes. So the last part asks about what alternative measures we can come up with to.
You guys are doing something very similar. We could let these guys do that, at least cover that part.
Okay.
And then you guys can chime back with what you guys.
Yeah.
Okay.
You did.
All right.
So first, tell us if there's anything you disagree with them, and then go on to.
Okay. Yeah, I think there's plenty of stuff to talk about here.
Okay.
Get on. So I mean, we went about this the same way, which is to try to enumerate external costs, but I think we took a little bit more seriously the idea that we're leaving out very, very important things here, like pain and suffering, for example, is not included. If you just sum up healthcare costs, we haven't included the fact
We're doing out-of-pocket healthcare costs, but not the fact that most costs of healthcare is borne by the person who's ill or her.
Yeah, exactly. I mean, when you go to the hospital and you pay for them to fix your leg, they're not.
No, but we actually include that in the injuries because we do quality adjusted life years stuff. A pretty rough cut, but yeah.
I mean, obviously we have no good way of doing this. We just double healthcare costs. We found some. Yeah, we Googled.
No, but I think it's right. I mean, I think so many people often forget to do that. Like, most of the cost of healthcare is not the out-of-pocket cost, really. It's the fact that people wouldn't, like, if it were free, people wouldn't go showing up at the hospital trying to get treated for stuff, or go injure themselves and things like that.
Right.
It hurts.
Yeah. There's also the cost.
I mean, it's like what Gary was talking about. I mean, it's jointly produced, so a lot of those costs are not borne by the healthcare sector per se.
It used to be a lot worse than it is
What's that?
in the past.
To get healthcare applied
So
to
the personal cost.
to be
Think
cared for,
about
you mean.
surgery.
Not of injury, but
Think
to
about
be cared for.
surgery in 1880. There was, no anesthetic. Guys didn't know what they were doing. And they were pretty dangerous. I agree. No antibiotics.
Less good, right?
Yeah, you'd rather die. Go ahead.
And there's violence, and there's the cost of the criminal justice system. We acknowledge those costs. We did nothing about them. We didn't include them. But also we think that there might be positive externalities to alcohol consumption as well, which we have no way of quantifying, no way of measuring, and honestly no idea how large they are. And so that you could say that the co-student bargaining is most likely to apply to the positive externalities of alcohol consumption because, if I want you to be drinking, I can buy you a drink. But so that's one argument. I have no idea. It's like I'm pretty sure that I'm more fun to be around when I drink, yet nobody ever buys me drinks.
But they could subsidize you in other ways.
Yeah. So we're going to assume that positive externalities exactly cancel out the criminal justice system and violence induced by alcohol. That's going to be our assumption.
Violence induced by alcohol.
Yeah, so there's got to be some externality effect when I drink. I'm more likely to be violent or bright. Right? And some people, I think, would argue that those costs are enormous.
Also, when you don't drink alcohol, you can eat people.
There's that too. I mean, it may also be that when you drink a small amount of alcohol, you're a safer driver. I don't know. A lot of people get pulled over for drunk driving or driving too slowly. So anyway, the only actual difference in our calculation is that we just doubled healthcare costs to account for pain and suffering. But the other thing is that there's this thing in this table that says something about how there are hospital days saved by drinking and hospital days added by drinking, and they're more saved than added. And the little I know about the studies that I think produced those, I'm very skeptical that those numbers are meaningful. But we threw that in as a positive externality through the avenue that everybody's insurance pays for their health care. So saved hospital days are a positive externality.
Wait, how do you save hospital days? By drinking?
It's healthy if you drink. If you drink a glass of red wine every day, or you die younger, right? They both. I don't know. But my understandings of those studies have fallen into disrepute these days. But there's another small point which we will point out because we want to be flexible that we have to take into account, which is that some of these accidents would have happened without alcohol. So you should adjust for the sort of the but-for world where some of these people who might be worse drivers on average anyway would have gotten into accidents without alcohol. Okay. So, I mean, I think mechanically we did exactly this, and we came up with something exactly in the middle. The lower bound and upper bound, we got 41 cents, which is the optimal tax. So did I miss anything there? Sorry. So that'll come into the next section, right? Yeah. So there was a difference in our analysis when we got to calculating like the lambda that was the lowest lambda where you still want to have the tax, and that's that. I'm amazed that we did the same thing. I'm not sure, but we calculated the true expected marginal price of drinking by including some of the non-external costs that are in the table. So like when you're drinking, you're not only paying $1.50, but you're also paying for the expected cost of healthcare, or not healthcare, but the expected cost of.
What did you guys do about like the tort system? The fact that there is a tort system out there today. It's like the experience rating and all the rest of it. Doesn't that have to be subtracted from your optimal tax?
Yes. So the optimal tax that we're stating, the 41 cents, implicitly assumes that we've completely wiped out any penalties for alcohol consumption, any accidents, anything like that, and we're starting completely fresh. Now, for the next section, we have to take into account that people do face these costs when they're choosing how much to drink. So what did we do? We estimated that by just adding the pain and suffering style thing. So we just added healthcare costs to the price that people are paying right now for alcohol. We could have done more. We could have thought more about what happens if you go to jail or what. So all we did was say you're going to take into account the fact that there's pain and suffering to you when you get in an accident. So the implicit price that people are facing instead of $1.50 is like $2.30.
But where does that come in the analysis? Since presumably you would face that in the but-for world also. Why does it matter?
All I'm saying is that when I'm choosing whether or not to drink, I take the fact that it increases my likelihood of getting in an accident that's painful into account.
But why do you even need to know what that number is? Why does that number matter at all? I mean, there's a zillion things that cause that demand curve to be where it is. How much I enjoy drinking, I don't like the taste, I do like the taste, whatever it is, there's a zillion things that add up to make that demand curve. Why do I care about that one?
So, we have this, I think, doing one of these things where we want to estimate the size of a triangle, right?
I understand, but it's internalized.
So we need to know the.
You just want to. You're kind of re-representing the demand curve in like a different space, basically. You're like computing something about the demand for alcohol if it didn't cause me to drive drunk or something like that. Some counterfactual rule. So it's just like you're representing the demand curve of a different good, which is alcohol net of the fact that it makes me drunk driving. Just like Kevin was saying, like you could also think about alcohol that didn't taste bitter or something like that, and that has like a different. In some efficiency unit sense, you can just kind of like scale the demand curve from that. The question is, why does that matter for this calculation?
So
as long as you do everything in the same unit.
So we know the total tax that we want.
Right.
And we need some sense of what the current tax is to estimate No?
No, because you're going to add that into the current tax, but you're also going to add that into the current demand curve, and it's just going to, it's not going to matter. Kind of, there's no, for the things that the guys are internalizing, there's just no reason to even worry about this. They're just background things. Don't spend any time trying to figure out the things that are internal.
It only matters because we're using the elasticities to calculate the reduction in quantities if you impose some kind of taxes to offset the social externalities. But I mean, what we all mean is that the initial position of the
No, but then you really don't want to do that, because the elasticities that people calculate are with respect to the actual price, not with respect to the full price. And people make this mistake a lot. They say, like, there's a time cost. And so let's add the time cost into the money cost to get, like, the true cost. And then they say, well, that's my true demand, and I'm now going to use some elasticity estimate. But the elasticity estimate from the data was with respect to the market cost.
You would need to go renormalize those estimates.
Those elasticity, the guy who calculated elasticity didn't divide by the full price. He calculated, he found DQ, and then he divided by some price, multiplied by some price to get the elasticity. The price he multiplied was the money price, not the price including this other cost.
So you can do it in these units, but then you just got to renormalize those elasticities to be in these full price.
You're just going to undo what you did.
Exactly. You're going to both multiply and divide by the same number, basically.
Exactly. You have to be careful not to do that, because you have to say what units. The elasticity was calculated with respect to the money price, not the full price.
You can do it. You just have to do it on both. You just got to make sure you're doing both things. You're using both numbers in the same space, basically. Yes. There's like the elasticity for a different good. You just got to transform that.
That's why.
Okay. So, I mean, that said, I think we get basically a very similar result, which is that basically the optimal tax on land is minus 0.2 is, in our mathematical framework, negative.
Yeah.
So what does that mean exactly? Yeah, I mean, it's not crazy, right?
So what does that mean? Kevin already has done these calculations, but I haven't. So where does that come out of the numbers? We have T star equals blah, blah, blah over there. So
just take their formula and just put it into some units of math.
Sure. Like should be maximizing positive tax. We're talking about the deadweight loss of taxation. So if we're going to be subsidizing, we should have deadweight loss of subsidy, right?
No.
Distortionary taxes.
Well, no, this is where it matters how we're going to use the money. The more
yeah, absolutely.
That's the reason so the government gains money so because the loss just still enters. And when the government subsidizes, it actually gives you more per dollar than it gives you like. Except the government spends $1, but it gives you $1.20. So it clearly doesn't make sense to do that when it's subsidized because the government doesn't give you.
No, I mean if by forcing the government to subsidize alcohol, you can prevent them from spending $1 on something that has only 80 cents worth of value.
Right.
Then in fact you would bring the 20 cents. This gets back to the thing we talked about yesterday. Is that a sensible but-for world? To say, if the government had to subsidize alcohol, which is a dumb thing to do, but it's better than the alternative, which is subsidizing alcohol wastes a little bit on the dollar, more less than 20 cents on the dollar. So
right, yeah, but so it's assuming that it wastes less than.
Well, no, you calculated it's less.
That's not an assumption, I guess.
That's what
the other assumption.
You calculated that the deadweight loss of subsidizing alcohol is less than 20 cents on the dollar. That's what your formula calculates.
Right. I mean, it also depends on exactly how the government raises the money that it uses to the subsidy now.
No, the idea here is the government doesn't raise the money; they spend less.
Yeah. Okay. So if that's true, then our result is that we should subsidize it. And I'm saying
it's you should waste your money subsidizing alcohol rather than
But if you want to break this weird subsidy result, we can say the government's not going to just stop spending on something else. It's going to
raise taxes,
somewhere else, yeah.
and then lambda is going to be positive rather than negative. So then you're in a corner.
Then you're in a corner.
But what is that formula? Does anybody? Did you guys work out what it is? I mean, just
I'm just doing it, yeah.
Just substitute in. It's easy.
So lambda is minus 0.2, is that right? And this externality we're saying is on the order of 0.4.
No, but just substitute. Get the formula for elasticity. Substitute his signal formula in.
Right.
And so it's 1 over sigma. So you just get the Q's cancel.
Get rid of the elasticity of supply, call it affinity. So.
No, it doesn't matter. The Q's cancel.
Yeah.
Right? So that second term becomes P lambda P times the thing in brackets there. 1 over the elasticity of demand minus 1 over the elasticity. So 1 over, I can't read it. Minus 1 over elasticity of demand. It should be.
Yeah.
Okay? And then, then you got MC. That makes sense. And then you got, then divide everything through by P. Because you want, then it just tells you, so it's T star over P, which is the tax, optimal tax as a share of the price. Equals 1 over 1 plus 2 lambda. MC over P. Yeah. Plus lambda times that. Exactly. So it's Jesse saying make the elasticity of supply infinite. Elasticity of demand for alcohol. What do you guys use?
4.14.
What?
4.15.
0.15.
We use 0.1 or 0.75.
I thought the data was that alcohol demand was pretty elastic.
And if you break it down, beer, wine, and spirits are very inelastic. Beer is very elastic, and wines.
Yeah. That's probably the problem, because we just used the number for beers.
Okay. So you're making it hard on yourself by making elasticity low.
Yeah, that makes sense.
So we'll make hard term.
Well, I'm going to say make it hard to have an optimal positive. And you're more, so you can see what really matters. What really matters is if the externality is a small part of the price, it's really hard to get. To make it, there's a huge rectangle relative to the triangle in that world. So it's very hard to have the tax improve welfare if you waste it into revenue. So it sort of says small externalities aren't worth using for moving taxes. Big externalities, which kind of makes some sense. What do you get, Jeff?
I'm also trying to
Yes, I think that's the way I would think about it. So what did you get as your optimal tax?
What?
What?
40 cents.
40 cents. Minus 40 cents.
Minus 40. So 0.7. If you put it to
0. What elasticity?
0.7.
0.7.
Yeah.
Okay, that's a. Okay, that's more like.
You put it to 1, you make like 9 cents with elasticity.
So elasticity's got to be, well, over 1 to make it worthwhile having a positive tax.
Yeah.
So we tax whiskey.
I got a bigger subsidy than that.
You got a bigger tax.
Orders of magnitude bigger?
No, no.
So you got marginal cost as what? And P is what?
I put in 0.4 and 1.5 for those respectively. I don't know.
Yeah, but I mean,
Just because those would sound like the numbers on the board.
oh yeah, there's this other thing we were talking about, which is what does the alcohol industry look like? Do you know the marginal cost of making beer is not 150, it's much lower than that.
Well, there's already a significant tax. That's another thing you got to take into account. We've already got a substantial tax on alcohol. So when you're sort of saying, you'd want to kind of back the tax out and say, what would everything look like in the world without the tax? Because it's a little bit like the tort system. It's already in there. don't know what that. Steve, you know what the tax per ounce on alcohol on average in the U.S.? It's pretty substantial.
I don't think it is very substantial.
It's like 20-something, 26.
I thought it was less than that.
Spirit?
I thought it was higher on spirits and not very high on beer.
That's what I.
Spirits
That's
at
what
21 cents per ounce. Wine's at 8 cents per ounce.
Okay, so it is 21. That's what I
21
thought.
spirits, yeah.
So about half your, it's got like half the externality. You would be saying it's internalized at about half the externality on spirits.
But actually, most of the crashes come from beer.
And so beer is more elastic, according to you guys. The elasticity of demand for beer is bigger. Smaller?
Beer's not.
I thought you guys said the opposite. Somebody said that the elasticity of demand for beer was higher than alcohol. No, beer's lower?
Spirits are higher.
You're saying externalities are bigger on beer?
Yes.
The data was that beer consumption was responsive to the tax. That's what people point out.
What's hard to estimate this stuff is there's almost no panel data variation
Across
places, and nobody's changing these taxes very much.
Were there a few places that raised the beer tax?
Really are. When I tried
Wisconsin or something.
So I tried to use the tax as an instrument. It's just incredible how once you put in state fixed effects and year dummies,
There's just no tax variation.
Right. So Grossman and people like that have tried to use it, but I think it's kind of a joke.
It's mostly cross section.
Mostly, or time series
Time
coming
series,
from
like
the nominal from inflation as opposed to actual inflating.
And then, yeah, because most of the spirits taxes are federal.
Right. And they haven't changed in like 20, 25 years. Once in 20, 25 years.
What about variation? Have anybody changed the way they sell spirits? Like some of these places, like
Blue laws,
Blue law.
drinking ages.
Yeah, but there's also
government stores.
Yeah, I was going to say there's also government monopolies.
That just never changes.
Yeah,
That's the
that's
problem.
locked in.
I was hoping there was some place that got rid of their government stores.
You know, it was kind of an interesting paper by Coleman Strom and this other guy where they looked at after Prohibition, county by county, you got to vote on whether you'd be dry or not dry. And I don't remember exactly. It's a little different, but
like where the
where
the marginal passage in the marginal.
Exactly. Then you had a lot of variation over time in how easy it was to get alcohol. And they didn't have price data, I don't think, exactly, but you could presume that would make a difference. That might be a way to get at it in a more historical time.
Couldn't you do it from supply shocks too? Like, I remember 2 years ago, Massachusetts, there were like hops is in shortage. Like, there's less hops this year. I don't know if they raised their beer prices or just restrict quantity because of that, but you could do something with the agricultural side of it.
Adding hops is such a tiny input in the cost. That's the problem. It's all like, I mean, a thing.
It's all put in a can.
Yeah, training and driving the trucks. I mean, the oil prices.
It's like everything. It's like every agricultural product out there. It's always the off farms.
So I guess there's one last part to talk about, which is why these taxes are stupid. It's better taxes. Because a lot of people engage in alcohol drinking behavior that doesn't have externalities, and we're punishing them. So it seems like the obvious thing to do
Most of
is
the action was coming from these deaths from drunk driving, not from all the other stuff that is associated with alcohol.
It seems like the obvious thing to do, if possible, is just to make people internalize the cost of winning if they kill someone. So that is probably not possible. But you can't penalize someone so heavily when they actually kill somebody. to only make them internalize the cost.
Yeah, it really worked out like in the world where you have like guys who have externalities and guys who don't. And if you could target how much you internalize in a world where you don't target versus you do target, it's actually a useful thing to work out. Just to sort of look at. Think about the two kinds of users. There's guys who have externalities and guys who don't. In one world, you have to tax everybody equally. In the other world, you get to tax the abusers and not the users. And then look at how the optimal tax, how the amount of gain you can get varies from targeting as a fraction, as a function of the fraction. Right? Because that's really what you're talking about here. That if you have to tax everybody, what's interesting is the optimal tax is still the same average tax, because you just kind of calculate the per unit tax, and that's what you do. They're equally responsive, but the amount of gain you get is very small relative to what you can get if you use it. And then you can overcome this land and all that stuff.
And there's another thing that you, in principle, could do, which is to tax each unit of alcohol that somebody consumes in a given day. I mean, if the externality is constant, I don't know how you can accomplish that.
How do you avoid the arbitrage?
And we're also saying that if you want to buy some alcohol, and they can make you have to make flow to see whether you're drunk or not, and if you are more like above a threshold, they will charge a higher tax than the one that is without.
You're going to send a delegate how someone who's not drunk to verify you are drunk, so. What I mean,
Yeah, it's hard. And that's what's tricky is like a lot of these different things are perfect substitutes in supply because the stuff's storable and tradable. So it gets hard to, even if they're not perfect substitutes on the demand side, it gets hard to impose different taxes on different units.
We can definitely raise fines for bad driving.
Right. Yeah. Yeah, and that's why they do stops and stuff like that because that's a much more targeted tax. And just like you were saying, it's like allows you to apply ex ante before they kill somebody. When ex post, it's very hard to make them internalize the full cost. Because nobody has $5 million.
It seems like the thing to do is tax them maximally when they do kill someone, because that's the super efficient way to go, right? And then you can't need some more on top of that.
Yeah, you can't take $5 million away from those people because they don't have it.
So you can add to that a penalty for being pulled over.
Right.
You can get more of the way there.
It's more efficient to kind of tax them ex ante because they're judgment proof ex post relative to the like the amount that they have relative to the $5 million is so small that they're effectively judgment proof ex post.
Yeah, but the effective fine for drunk driving arrest, with these kind of orders, it costs about $10,000. I think that's about the fine you would get. You take, again, you're just doing the same thing. You take the total cost and divide by the number of drunk driving arrests.
You're saying the optimal fine or the actual fine?
No, if you use numbers like these 40, you guys are getting like 30 cents an ounce.
Yeah.
You divide that by the number of, multiply by the number of ounces, divide by the number of drunk driving arrests. And if I was going to tax people on drunk driving, the optimal tax would be like $10,000 per arrest. Not per incident of drunk driving, because you don't care. You don't care about that. You only just care about per arrest.
So then people are much more likely to be able to pay.
Yeah, that's getting still difficult, but it's more likely than the 5 million.
Yeah.
5 million when I kill 5 people.
But there is
and on that scale, you could mandate that they're insured for that. Or
the drivers who get pulled over are not the dangerous drivers. There's that. You have to think about that too.
Yeah, you would. You would. You'd have to say, is that a good meter? Right? The question of all this stuff is what's a good meter of the activity that you're trying to stop? You could ask yourself, why do I tax alcohol, not cars? I mean, in principle, you could say I'll tax cars rather than alcohol. There's no difference. I mean, it's probably even less targeted, so I'm not arguing it's better, but it's the principle is the same. In any case, you've got an imperfect proxy for what you're trying to stop. So, any ideas on what you would tax? You got drunk driving. You would tax everybody who gets pulled over drunk. What else? Any other thoughts you guys have?
So there is this incidence for the drug shop laws.
make the guys who sell the alcohol
Yes,
responsible.
so okay, because you don't have this ability constraint, less ability constraint, so exposed to the less judgment. But it's difficult, but it's probably it's not non-constructive. They cannot make roads and contract. I'll tell you.
Make a grocery store or someone in the case of beer responsible. That seems hard. I mean, it's getting harder and harder as you get it's easier for the bar owner or whatever. You make households responsible. Somebody comes over to your house and drinks.
But so I guess for that, we also have to know how much of this actually is when people come over, go to someone's house. I would assume that a lot of that is going at the bars. So.
Steve, do you know where all the drunk drivers come from?
Where do they come from?
I thought they were all on the rural.
They're all at night. What?
Oh, no, I don't think we know
wherever they were drinking.
But they're mostly at night. I mean, road accidents, surprising amount of highway deaths in general occur at like hours where nobody's on the road.
Right. And by our estimates, Jack Porter had estimates, we estimated that I think 40% of the people who were driving at 3 in the morning had to.
That's true. I can tell you for sure.
Yeah.
And the rest of them are high school students who are even more dangerous.
What's the avoidance cost of people who don't want to drive in the middle of the night because they're going to get hit by a car?
Yeah, that's the picture we put on the board earlier.
Right. Like I think a longer bike perhaps works.
Yeah. You knew the elasticity of demand of activity.
So there's one last thing that we sort of thought of the last second, which is that you have this technology that can actually make people not drive when their car just doesn't work.
Yeah, but then you just get someone else to
no, let's say it's
get a sober
perfect.
person to like.
And most people who are drunk driving might be by themselves in their car. They don't have something. I don't know, but even if that were the case, let's say lambda were 0, it might be better. It's a non-distortionary tax, so it might be better to use the price mechanism than the device and stuff.
It depends on how costly it is to use the device and how much. If it was very costly to roll into the device, you have to consider the cost of itself, the device itself, which is really
Right. Well, if the cost is 0.
oh. And it didn't take time to roll into the device.
Right.
I was out of the room, but did we talk about punishments for drunk driving at all? Because we're trying to, so we talk about that.
This is a slightly different question, but let's say you were at a party and you got drunk and you had your car there and you were about a mile away from home. What do you think should you drive home or walk home?
Depends. You face more risk of killed by walking drunk.
Yeah. Car provides a lot of protection. It's like walking home wearing armor or something.
Privately, you're 8 times more likely to be killed walking that mile than you are driving. But just in general, to include everything, 5 times as many people will die if you walk home than if you drive home.
So socially, it's opposite.
Socially, it's opposite.
A little bit of self-help advice. All right, should we come back at 11?
Yeah, we'll come
All
back.
right, thanks, guys.
Our next group goes.
So our project actually has to do with capital punishment, another policy issue that has been a matter of tremendous contentious debate. And the idea that we're actually going to explore is has to do with this idea. Proponents of the capital punishment people propose that if you have higher execution rates, perhaps that in itself can actually act as a deterrent for future criminal activity. But before we jump into sort of like the theoretical framework that we're going to use and the empirical strategy that might allow us to actually, in fact, infer this relationship causally, I'm going to introduce briefly some of the facts about what we know and what we think we know about the relationship between the two variables. So the first graph that you have is basically the U.S. map by the status of the state statutes related to death penalty. As you can see, most of the U.S. states, I think 34 of them, have a death penalty. Interestingly, 2 of them, Kansas and New Hampshire, are states that have the death penalty, but actually haven't executed people since 1976. A minority of the states, the blue ones, mostly in upper Midwest, I guess, and New England, are states that do not have the death penalty embedded in their statutes. Now, an interesting fact about some of the red states, if you know something about capital punishment, you probably know that in terms of actually number of people executed, in terms of number of people executed, Texas is actually the highest, the state that has the highest number of executions. Adjusting for size of the state, it's actually Oklahoma that has the highest execution rate per 100,000 residents. In terms of all the states, the 4 highest are Texas, Oklahoma, Florida, and Virginia. An interesting question mark about those states, actually, if you just sort of like preliminarily look at on the very surface, the relationship between the 2 variables, the execution rate and the homicide rate on the other side. What's interesting is that, in fact, those states, with the exception of Virginia, Texas, Oklahoma, and Florida, in fact, you see a very high criminal activity. They're one of the states. They're towards the top, in the case of Texas, actually pretty high up in criminal activity. Virginia is the only exception. So this kind of challenges, or perhaps is slightly inconsistent with this idea that the higher the execution rate, the more it might actually determine for future homicide rates. This graph sort of gives you the movement of the 2 variables across the last century. You have on one hand the homicide rate measured by vital statistics data and FBI, primarily to sort of to eliminate some data measurement problems, and on the other hand, you have the homicide, you have the execution rate. Now, if you notice, in the very beginning of the 20th century, between 1900 and 1910, in fact, the movement of the 2 variables is sort of like exactly in the opposite direction that you expect. The higher the execution rate, the lower the higher the execution rate early on. In fact, the higher the lower the homicide rate. Sorry, the other way around. The higher the execution rate, the higher the homicide rate. And so it's not until 1920 and 1940 that, in fact, you see sort of the kind of this movement that you expect if you believe the proponent's argument, that the higher the execution rate, the lower the homicide rate. The relationship becomes even more problematic after 1940s and 1950s because you essentially see sort of the same movement of the 2 variables up until the 1990s. And in fact, what's even more puzzling is that after 1976, when there is the repeal of the suspension of the death penalty, you see the homicide rates remaining pretty high. And that said, I'm going to pass the lead.
All right. So now we've kind of seen some homicide execution rates in the United States. We'd like to kind of make some comparisons of homicide and execution in the United States to other countries. So this will be the United States and Canada. These graphs are all from Wolfers and Sonic. They have pretty good summary statistics, so we thought they were pretty good to go with. This graph has a lot going on, but it helps explain a lot of things, so I'll describe a few different things. First off, the top line there is the homicide rates in the United States from 1950 to 2004 or 5 there. The lower line there is Canada's, and they're on different scales. Here, if you look at the right hand, well, I guess my right hand there is Canada there and the United States. But we're going to look at here is look at these homicide rates of death penalty because the United States and Canada had very different policies on the death penalty. Specifically, when it was legal in the United States, it might not have been legal in Canada, and vice versa. So I'll go through a couple of major decisions here, and we can see that these two seem to move pretty close together here. Even though the United States levels were always higher, the trends seem to move in the same direction. So I'll go to the United States first here. And the two lines I want to look at here are the Furman decision and the Gregg decision. So up until the Furman decision, death penalty was legal in the United States. In 1972, the Furman decision said it was unconstitutional. Not unconstitutional, just suspended the death penalty entirely. From 1972 until it was overturned in 1976 by the Gregg decision, and then states could make up their own decisions like that map we first saw. However, in Canada, the choices were very different. In the beginning, they had the death penalty, but then they completely basically abolished the death penalty in 1968. The only exceptions in Canada were if you killed a police officer or a cop. So pretty much there was no death penalty in Canada after that. So you can see that for this entire period back here, there's death penalty in the United States, no death penalty in Canada. The trends seem to still move together even though they're very different policies about the death penalty. In fact, if anything, it looks like the gap even gets wider and there's more homicides in the United States. But Canada and the United States are pretty different countries, so maybe we need something else for a comparison. So what we're going to do is compare, some states have death penalty laws, other ones don't. An important thing to mention about that first slide there was some of the red states have the death penalty in the books and they have executed people. They haven't executed very many people. They've executed 1 or 2 people in 30 years. But anyways, what we're going to do here is take a look at the states who have the death penalty and the ones that don't. So the states that have the death penalty over this timeline, as the graph is the solid line, and then the non-death penalty states is the dotted line. And you can see again, it's kind of interesting that in the states with the death penalty, homicide rates are always higher. I don't know what way that causation might go, if that's the reason they decide to adopt the death penalty or not. But again, you see the trends basically move together. There's a few little gaps, but they seem to move in the same direction. So this doesn't really give any insight that these states with the death penalty are causing a very different effect than the ones without the death penalty. But so that's most of the background information. I think Joe's going to get into the
pointer. So I think everybody believes at some level deterrence works. Like if you told us we would be executed if we went over 15 minutes, we wouldn't do it. But the decision for criminals is a little more complicated. So we wrote an optimization problem here, and then Claudia and I went back and forth and talking about how this relates to data. This is the most general we could think of. So it's in a few lines. But we imagine each criminal I has to choose their optimal decision, and their choice could be to kill somebody, or to do a violent crime, or any other sort of crime they might do. And they choose the decision that maximizes the expected utility. And given a choice, they don't know what outcome they're going to have. So if you kill somebody, you might be executed, you might get life without parole. There could be lots of other outcomes, like not even being arrested or just sitting in jail for a little while. And so for each outcome, they think about the probability they get the outcome given that they commit a certain crime. And then this thing here in brackets is the expected utility they get from doing that outcome given the crime. And the reason it's a little complicated is because they're forward-looking and they're thinking about the rest of their life. Let's just explain this. So they look forward and they have a discount rate. This thing is parentheses, so you could make it exponential or hyperbolic or whatever you think criminals are doing. And then they think about whether they're going to be alive given the crime they did, and this is conditional on the choice because, like, if you don't commit a murder and you're supposed to, the mob or your gang might come after you and end your life, so that one's conditional. And then here, your utility is conditional on your choice because people might feel regret or satisfaction or different kind of utility based on their choice. So this just says people making a discrete decision to maximize expected utility. And then the thing we were interested in is the expected change in murders based on changing the probability that somebody's executed given a murder. And the reason we put variables here is that there's probably going to be a different effect for each individual person in the population depending on that person's discount rate, whether they're a member of a gang. And there's no way we're going to estimate an individual effect for each person. And it also seems unlikely to accurately estimate this mean effect, but that's what we're interested in.
Yeah, so do you know what the average length between, like being convicted and executed is?
15 years between crime and execution is average.
And like
so if you
how
did
long?
5% discount rate, it would be like 50%.
Oh,
Something like
sorry.
The thing is that that's among people who are executed.
Yep.
So among people who are executed in a given year, the average time in prison was 12 or 13 years. The problem is that some people just might not ever get executed. So the expected length of time that you spend in prison before
Well, I think you guys are saying there's ambiguity about what these parameters are, and we agree and we'll show a bunch of different parameters, but it sounds like you're saying this sort of discounting framework is what you think.
Well, I'm just wondering like how close being, sentenced to life without parole is to being executed. Like if, life without parole on average is 20 years and on average it takes 18 years to get executed.
In 2 slides I'll show you a bunch of the numbers.
Okay, so if we were trying to think of some estimate of the deterrence effect provided to a policymaker or something, there are really 2 ways that we can go about doing this. So one is to take this decision framework that we have, think up some plausible estimates for the parameters that go into the choice. So what are some estimates of relative utility of the outcomes given the choices, and some estimates of the discount factor and probabilities of being alive conditional on murdering and not murdering. So that's one way of doing it. But if you wanted something that was more rooted in data, but you didn't have time to do a whole sort of analysis of the effect of some law change or some exogenous variation in the probability of being executed conditional on murders, on the number of murders that occur, you could take a decision, you could take some estimate of this effect, so the change in the probability of being executed, the effect of that on the number of murders, but maybe not look at the probability of being executed, but the probability of death from some other cause that is linked to being in jail, and use that kind of as a proxy for the probability of being executed on death row. So basically, what I'm saying is if there's some variation in probability of death conditional on murder and conviction, then you can look at someone has some estimate of the effect of that probability on the number of murders. Then you can kind of use that estimate of this expectation as a proxy, maybe for the deterrent effect of the death penalty. So, going on that, there's a paper by Larry Katz, Arvarian Steve, and Ellen Schusterovich that looks at deterrence effects of the prison conditions on number of crimes. And specifically, what I'm using here is basically for each additional death that occurs in prison not due to execution, how many fewer murders do you see? How many fewer murders do you see in the population? So basically, this estimate can range. So the estimate of murders prevented per 1,000 people in the state population due to an additional. This should be death, not execution. Sorry about that. So if we see an additional death per 1,000 prisoners, so an increase in the death rate per 1,000 prisoners, if we see estimates of the number of murders outside the prison that are prevented in the neighborhood of -0.01, then if we change the execution rate counterfactually, if we increase it by one execution, if the execution rate were 1 execution per 1,000 murders, which is the average since the death penalty was reinstated in the United States, that's maybe based on this estimate of the deterrent effect of death in prison of -0.01. The death penalty has then prevented around 30 murders. And then this deterrent effect, or likely deterrent effect of the death penalty increases as the execution rate per 1,000 murders increases. So so one in the average execution rate from 1976 up to 2004, but in some years the execution rate is higher. So in a year where there were 5 executions per 1,000 murders, you would expect that those executions would have occurred 145 murders. And similarly, if the deterrent effect gets larger, you see larger numbers of murders deterred. So that's interesting. And since the average rate of execution per 1,000 murders has been around 1 over the past, we think that maybe criminals are operating off of that benchmark. So, so the death penalty has maybe prevented somewhere between 30 and 200 murders per year over from 1976 to 2004.
What does that imply about murders reduced per guy executed?
Murders reduced per person executed. So this is.
Is that kind of a metric?
It's like in that second row, it's like 60, right?
That's what that third column is, I think. It's murders, it's just in different units.
I mean, it's just it's all of the columns, and then like in the second row, it's just like
I know, but it's in the.
No, it's like 60. Well, there's 60 guys. The first column, they're like 60 guys a year, 50 guys a year, maybe being executed.
Exactly. Yeah.
So we're talking about
like
one. So those are really. So you're coming up with.
But isn't that a better way to present the unit? I mean, I don't know what the right way to present the unit.
Yeah, I mean, so I was basically doing this so that these would be multiplied through equally, and then these are like population weighted. But a better way to present it would be like, divide these numbers by 10. So you have like the execution rate per murder population that is, 0.1%, 0.25%, 0.5%. So I don't know if that's.
But if we went back to 1900, we did like 100. We'd be like over there.
Let me think about that. It wouldn't be. These numbers wouldn't be.
Top number would be like 100.
For some years. There's a lot of variation in the number.
But it would be on that order of magnitude.
Not on average, though. I think on average it would be like 60.
I know, but still, we would be at 12 times that last column.
Yeah. But the thing is, I mean, that's like, I think part of this also is that the deterrent effect might be like increasing over the murder population, So seeing as there are like, I think there are more murders. There were more murders per population than there are now, right?
So you were looking at a fraction of guys executed. There was a time at which we executed 10% of the guys, 1 guy for every 10 murders.
Yeah. Well, all I'm saying is like maybe now, maybe back then, since we're on the, going out on the, if there were more murders, like maybe, you needed. I guess I'm just saying maybe there's a diminishing effect of the deterrent effect. So, yeah.
On the basis of what?
All I'm saying is that maybe you can't extend the split.
I don't know what is increasing.
Next slide.
Okay,
Yeah. I mean, I guess a simple response to the question is that there's no basis to assume that any of these deterrent effects would be linear in the execution rate.
Maybe more than linear, less than linear.
Exactly. Yeah, exactly. So, but this is just, if you wanted to spit out a number to policymakers in 24 hours, then this might be a baseline. But another way to do it is to calibrate a model.
All right.
Those numbers are probably too big too, because those are not actually looking at executions. They're looking at death because of bad prison conditions. And so there's a lot of other things that go along with it. Well,
metering the conditions.
Yeah.
It's a meter of a lot of different other conditions.
There's a lot of deterrent effect. Unpleasant before you die. Is death row unpleasant before you die?
I think death row is pretty fun, actually.
There's a lot of suicide.
Death row? 8 times.
Yeah, so I'm definitely not trying to argue that the deterrent effect of prison deaths is comparable to the deterrent effect of the death penalty. It's just that perhaps it's impossible.
Yes.
And if you couldn't do your own study, then maybe you could just pull some data.
So it's hard just to look at that model and to guess what people's disutility is of execution, the alternative to execution, which could be like without parole or something else, and also how much utility they get from killing somebody versus just stealing from them or not doing anything. And we don't really have an opinion of what the magnitude of those are, so we tried to simplify it as much as possible. And then I only really take one conclusion from this exercise, which I'll tell you in a second. So we took that like original version of writing out the model, which said everybody who commits a crime does it at age 28. 13 years later, they have a 1 in 300 chance of being executed. And if they weren't executed, they would live till 75. That simplifies things. And you also need some heterogeneity among people, but some things that aren't heterogeneous among people that have any traction. So we just said different people have different utility, A to I, from committing a murder rather than a crime. And then all this other stuff, which is like the next best alternative, is the same across people. So this thing is a number, which is the same for everybody, and this is the probability to get executed, commit a murder. And then the market share of people who decide to commit a murder is like the number of murders we actually see in data. So the closest thing to murder, which has broad aggregate data, is potentially violent crimes. There are about 1.4 million violent crimes each year. So you can make any distribution you want for this, and really the choice of a distribution, all of it determines whether the deterrent effect is going to be increasing or decreasing. But it seems reasonable to think the tail is going to thin out here. Again, this, you just pick a log normal distribution here, but this is like a random utility term of how much you like murder relative to the next best crime you're going to do. So this is not actually 1.2, but we drew it to be big so you can get an idea. So here's the utility you get from doing murder. This is the PDF. And this tail is the share of people who decide to do murder rather than commit another crime. And so you can imagine cranking up this probability to get executed given that you commit a murder. And the effect of that is basically going to be to move this cutoff over here. So there are going to be fewer and fewer people who get higher utility from committing murder versus doing the next best crime. So to actually get any estimate of the number of change in murders, we have to pick some kind of a baseline. So we chose that if you double the number of executions, you would prevent 200 murders. That seems pretty high given my priors. It's sort of in line with the previous table, but this is in terms of share of murders prevented, not number. So let me just explain this graph, and then there are lots of comments you can make about how it's right or wrong. But here on the x-axis is increasing the number of people you execute. So this is the current number we're executing, double, triple, quadruple. You were asking about executing 20 times as many people, that's over here. And the y-axis is the proportional change in murders. This is 1% decrease in murders, 5%. So the only point I take from this that might not be obvious when you first think about it is that if you think this framework is somewhat right and that people are getting some kind of random utility from committing murder, there are a few people out here in the tail who really, really want to commit murder. And even if they were guaranteed to be executed, they might still commit murder. But then, since the height of this PDF is decreasing over here, because you're in the tail of people who like murder, that's why you would get decreasing returns to the death penalty, because even though you're moving this very far out, the tail is not very big. So that's the idea I take from this. If you believe that framework, then you get decreasing returns to executing murder.
So what, did I miss where you told us what the relative utilities were for this?
We did, so I did not actually pick numbers for these relative utilities. We just said, we are going to assume if you double the number of current executions, you would prevent 200 murders.
Okay. But what was the point of the framework? It's like you assumed the answer.
We assumed some number here. We did not assume the shape of this curve, and the only point of this is to show the shape of this curve.
But isn't the point of the model so you can figure out, don't you want to use a model to figure out that if you double executions, would you reduce 200 murders?
I would like to do that, but I don't have any ex ante prior on what these three utility terms are. And so we thought using retrospective policy estimates to get some idea of what those terms might be is a starting point. I could say, if it were me, I would take utility of life without parole to be similar to the utility of committing murder, but...
So if you did that, what would you say?
If I picked the relative magnitude of those terms?
That's kind of the point. That's what Kevin said. It's a lot of what Kevin said a couple of days ago. A lot of what economics is like using some knowledge or drawing on.
Yeah.
Because I think So I think, I mean, another way to think about this is how different would do those utilities of life without parole and execution have to be to generate that 200? And I think that if you did that, you would find some insane numbers from it. But then how can, if you know that's true, then how can you come up with a straight face and say that I'm going to assume 200?
Well, I told you before that 200 seems too large by probably an order of magnitude. But if you took the numbers in the previous table literally, so an idea here is that the model is not right, like any model. We're trying to take it literally and see what it says. And I think what you're describing is maybe a better exercise, which is to figure out the number of murders prevented. And the point of this is a different exercise. It's to figure out if the deterrent effect is increasing or decreasing. And the only real point is that if you think there is a random utility from committing murder that has a thin tail, then the deterrent effect is decreasing. And that was not immediately
But
obvious.
the range over which you're talking, aren't we talking about going from 10,000 murders to 9,500 murders to 9,800? We're talking about deterring a few murders. That's why this diminishing returns seems to me to be hard to be a key part of the story, right? You're talking about going from, I agree, if you want to cut murders in half, then you get into a real different part of the distribution of guys committing murders. But the guys, you got the 10,000th guy and the 9,800th guy. I mean, hard to believe that this decline in the density is that critical in that range.
That's why I said you can pick any distribution you want, and it may not be this abrupt. The only point I take here is that it's declining.
I'm just saying, in a world in which you're talking about changing the number of murders, I agree. If you were thinking about, I've seen experiments that change the number of murders by 2%, and I want to say, what would happen if I'm going to change it by 20%? Then I got to worry about extrapolating. But if I've got data on it, changed it by 2%, and I'm interested in 3%, I mean, this isn't that critical, right?
That kind of follows from this, right? And you're not going to...
Take the data that was used in that paper. That was varying murders by much more than changing the death penalty ever would change murders, right? Because those were first order big numbers relative to the numbers you're talking about.
Yes.
So you're not talking about this kind of extrapolation problem.
Right.
Your number
It's an
is
interpolation problem.
It's an interpolation problem. So I don't even know why you'd want to think that those numbers are necessarily too small. I mean, too big.
I think this conclusion is completely independent of the number of people currently being executed and the magnitude of the deterrent effect in levels.
But you calibrate your model off of some experiment.
But this
some
could be
experiment was like a
10%.
movement along that.
Yeah, but this could be 10%. You would still have this shape. And the only argument we're making here is that if you believe this random utility idea, then there are decreasing returns. The doubling executions will have less benefit than.
But what does that tell me about how I should take Steve's numbers and translate?
We didn't do it because we don't feel we have a good sense of what the relative magnitudes of the utility terms are. And you're right, we could figure out how big the difference would have to be.
What if Steve's experiment was exactly the range that you were interested in? Then you would say, I don't really care about this nonlinearity, because Steve estimated the impact of a change on this order of magnitude, and I'm looking at the same approximation in the same area.
But you were just asking about 1900 when we were going.
No, I understand. 1900, I think.
So this becomes very relevant when you start asking that question. Because you're extrapolating far out, and the fact that there are decreasing
depends on how much
returns.
lower I think the murder rate would be.
Yeah, but you would want to know both. What's the level change, and also what are decreasing returns? So this is about decreasing returns, and the previous slide was about levels.
How much lower would you guys say the murder rate would be if you went to 1900 executions? If you just did the extrapolation.
Try writing it?
No, that's okay. You have an idea.
So
now we're executing.
So what's the 1900?
1 and 300.
Yeah.
And 1900 would be 30 and 300. Is that right? So it would be a 30-fold increase in executions. So this sort of thing looks about right. And like I said, I chose a completely arbitrary log normal density, but that would make it look like maybe 7 to 9% decrease in murders.
And when the linear extrapolation.
No more murders. Because look, this slope is so steep. And if you took it to be 20, it would be a lot shallower, but you would still have like, I don't know, 30% decrease in murders. The 1900 this starts becoming a lot more relevant. Or like if you're comparing the U.S. and Iran or U.S. and China, my sense is that this sort of thing becomes a lot more relevant. There are many other differences between countries, but
I think one important takeaway from this is that given the range of variation over executions that we're talking about, there really isn't that big of a deterrence of that.
What's the import of that?
What's the import? Well, I mean,
it's hard to detect empirically. That's what
it's hard to detect.
So we're hardly executing anybody.
Yep, that's why it's hard to detect.
Yeah, but if we're not willing to execute 30 times as many people, then
So why is executing people a bad idea just because we're not willing to do much? Or a good idea? I mean, I don't know. That's the part I've never understood about this.
Well, we're not doing a benefit cost analysis here just because that wasn't in the questions, but you could, and it might actually look like it looks a lot better to execute a few people than a lot because they're decreasing returns to execution unless there's a big fixed administrative cost. So that's an interesting.
So you're saying it's hard to detect the effective executions?
Well, both.
Both. So what's the other one? The one I understand why it's hard to detect the effective executions. What's the both? What's the other of the both?
Well, I'm just saying that, so if that were a linear line, then if we, increase the number of executions 30-fold, then we would see a huge decrease in murder. But since it's a decreasing line, that increasing the number of murders 30-fold isn't going to have such a big, increasing the number of executions 30-fold isn't going to have such a big impact on the number of murders. So, maybe, the marginal deterrent effect is increasing. So,
I mean, this is also not the social planner view. This is the criminal's exclusive view. So the social planner also wants to think about, like, people liking the fact that there is a death penalty and enjoying retribution, or people not liking the fact that there's a death penalty, or people protesting and having fun protesting, or whatever else. But it's not social planner.
Yeah. Well, maybe we should go on to. So we were thinking about directly estimating the deterrent effect, not using models and kind of out of nowhere estimates of the relative utilities of dying versus life on parole. Then we would want to look at some potential sources of exogenous variation in the number of executions, and then look at the direct effect of that on the number of murders and crimes in general that happen. So I just wanted to say one quick thing about murders versus crimes overall. If you're interested in the effect of implementing or taking away the death penalty on general crime, you really have to think about how people are substituting between murder and other forms of crime. If you institute capital punishment for murder, then people who were going to murder may just switch over to aggravated assault. So you might have that, the murder rate goes down, and then there's no overall effect on crime. But that said, there's been a lot of empirical work on the effects of the death penalty. So most of these bullet points have been done, but I will just go ahead and summary. So the first way is just you can look at changes at law at the national level. So like you showed in the graph, there have been two Supreme Court decisions. The first, Furman in 1972, which declared the death penalty unconstitutional, and then the Gregg decision, which overturned the Furman decision and made states able to execute people again. So basically that would just be, an experiment, and then you get the difference before and after. And since we have a lot of different states, we can look at variation across states in the response of number of murders to number of executions and get some sense of what was the impact of allowing people to execute them. So another thing that we can do is, rather than looking at a national law change, just do compare states that have had changes in laws, and then that's your standard difference in differences. And the added benefit to that is that you can use neighboring states as a proxy for the counterfactual path of murders over time when you look at the way the law changes in one state. So that's pretty straightforward. And then another thing you can do is do some kind of fuzzy regression discontinuity, where you're looking at the fact that for most states, juveniles and adults are tried in different justice systems, and the death penalty does not apply to juveniles. So if someone is
You want to use age as your running variable. Or something.
Yes, exactly. So the discontinuity occurs at 18, and it's fuzzy because some juveniles are tried as adults, but for the most part, 17-year-olds won't face execution, whereas 18-year-olds
We should
will.
probably wrap up so that the other group has some time.
Okay.
As long as you guys are close to.
I'm basically done.
All right.
So everyone knows RD is very straightforward. And one thing, if we were looking at, if we wanted to look at the overall effect of the death penalty on crime, we would also have to, not only would we have to look at these substitutions between crimes, but we'd also have to look at the effects of either implementing or removing the death penalty on prison resources, legal resources, and interactions between prisoners that might increase or decrease the number of murders once they get released.
Thanks. Group 6. You guys need the screen, or should I bring it up?
We can use the screen. Our slides are on the external hard drive, but I'm not sure.
What?
The jump drive.
That one is. Always good to bring the humor into the topic of capital punishment.
My job is to introduce our question, which is going to end up, I'm not going to have all that much new stuff to add, because in terms of our introduction is very similar to the other introduction. We even use the two same graphs from the previous literature as the other authors did.
Skip those and we can spend some time talking about some of the other
So just to say what else we're going to do, we're going to follow a similar path, set up a simple model, and then try to calibrate and get some idea of what the model means, and then give some conclusions of other approaches. So just, since I don't have to really talk about other graphs, maybe I'll just mention one thing about why I thought this cartoon was interesting. It turns out that when we do our modeling, one of the assumptions we have to make, which was touched on by the other group, is the assumption of the sort of the relative difference in utilities per year of being in, out of jail, in jail, or on death row. And this assumption that we make over that parameter in our model turns out to be really, really important and sensitive to the results we get in the model. And so this would be a case, but maybe we were trying to get information on that, and I guess elicit how terrible his life was on death row or something. So here's the two graphs we've already seen, so I guess I'll just...
All right, so our framework yeah, that really did help us save some time. So essentially what we're thinking of is a two-period model, which gives you annual payoffs. The baseline is if you're alive and you don't murder anyone, where you get utility U. And if you're alive but you have murdered someone, you get a premium, a multiplicative premium beta, which is your benefit for murdering, which is multiplied by U, and we assume that beta is distributed F, which in practice we use a normal mu sigma. If you're dead, you have zero utility. Because we noticed that the suicide rates were different between the prisoners on death row and the general prison population, we thought that there should be quality of life adjustments to these utilities. So we just made them multiplicative. And these factors are alpha P for people who are in prison but not on death row, and alpha D for people who are on death row
And we have the condition that alpha p must be less than or equal to, alpha d must be less than or equal to alpha p. Also, we weigh our future payoffs by a discount factor delta and state-dependent survival probabilities. Obviously, if you're on death row, there's this somewhat exogenous chance that you will be killed in a period. To get a better sense of what this looks like, essentially we think that it follows this tree. When you're thinking about whether to kill or to not kill, you compare the expected value of utility from killing to the expected value of utility from not killing. So as you can see, if you don't murder someone, things just kind of go along hunky-dory and you've got one path. It's essentially your utility from the first period as well as your discounted utility from all future periods of life. If you do murder someone, then you get beta U in the first period, and after that you can fall into three possible states. The first being death row, the second being prison but not death row, and the third being not getting caught. These occur with probabilities PT, PP, and 1 minus the different probabilities. As you can see, we have the discount rate that is the same throughout all states, and the survival probabilities change in the different states. The solution to this is basically a threshold condition, which is given by the expression above. Basically, the homicide rate is 1 minus f of beta. To think about comparative statics, one of the easiest ways to do so is to think about the case where we have constant hazard rates of dying in each state. So as you can see, if we decrease the survival probability in the death row state, then essentially beta star will increase, so we'll have a lower homicide rate. And I'm going to turn it over to Tom, who's going to talk to us about how we did the calibration.
So this is a bit interesting. It was my first exercise. Really, well, this is certainly my first exercise in trying to present some kind of a structural calibration, especially with only 2 data points. But so we decided to calibrate this using the reduction in prime in the 1990s. Steve, I think, thinks this is a good idea because he thinks the entire reduction in prime was due to the increase in natural function. So basically, between the Klein fell a lot, and at the same time, there was an increase in capital punishment. I'll show you some of the numbers in a second. So what we have to do, so we basically take these 2 data points, right? The change in execution rates and the change in homicide rates, and we try to calibrate the model. It's not going to give us anything realistic, but it's kind of a fun exercise. If we had if we had a better natural experiment, then we might be able to calibrate the model using more data. But anyway, we're going to give this experiment a try. One thing that we have to do is we have to make an assumption about the distribution of this latent payoff from murdering people, and we just assume that it's normal. It's arbitrary, but it's easy to calculate. And then I'll talk a little bit about what we do for the quality of life adjustments for life in prison or life or years on death row. But we do have some pretty good numbers on people's survival chances out of prison, and people's survival chances sort of sitting around in prison, and people's So the differences in survival chances in prison versus out of prison, and then sort of adding on the hazard of execution, conditional living on death row. And we're going to consider the survival probabilities of a 20-year-old male, because those are the people who are most likely to commit crimes. And that's what we show here. So homicide rates are very, very high among 4-year-olds. So a few numbers that are going to be important for calibration. Really, these are sort of working down to the most important ones, which are these 2 ones at the bottom here. So the probability of going to life in prison, essentially, conditional on homicide. and the probability of having a death sentence, conditional homicide. So actually, the probability of being convicted to death if you murder somebody is actually very, very low. And then if you look at the data, every year there are something around 3,000 people sitting on death row, and only 2%, somewhere between 0 and 3% of them get killed every year. So we take a constant hazard of execution of 2%. And so we throw all this together and match it with some outcomes data. And so these are just averages from these 2 decades. And what you see here is that the homicide rate, this is the homicide rate per 100,000. The homicide rate decreases a bunch between the 1980 to 1985 1995 period and the most recent decade. And you also see that the hazard of execution conditional on being on death row increases a bunch. So they started executing more people on death row. The other thing that's going to be very important for thinking about this is that actually sentencing probabilities, it's actually clearances, so arrest probabilities, conditional on homicide, went down a bunch since the 80s. Sorry.
Aren't you kind of assuming that, like, everybody who some of the people that commit a murder are brought to court, like, your 44% chance of being convicted, you're assuming that, like, the 54% people that are let go are the ones that did commit a murder? Like, so the justice system lets, like, 54% of the...
Well, it's divided by homicides, right? So...
Oh.
So it's like number. It's not for number of arrests. It's for homicide.
Okay.
I think that answers your question.
Yeah.
So aside from it, but murders happen independently, or do they come in bundles?
Sorry, what do you mean?
If you murder like 3 people at once, and then you get the same punishment, it's different. There's a different outcome for each different crime.
I assume for like gorier crimes, you're more likely to get to death. But yeah, I don't know that much about the criminal justice system.
Right, we can't really say much with the numbers about more than one murder per person, so we're just assuming one murder per murderer.
So this actually gets us into a difficult situation. This is something we realized late last night, so we couldn't use another quote-unquote experiment. But basically, if you imagine that we have some distribution of these betas, this is not. So if you have some distribution, right? And we're saying that there's going to be, just as in the last presentation, that there's going to be some threshold between the star, right, above which everyone commits murder. Now, the issue is how much people downweight the utility from life in prison versus how much they downweight it when they're actually killed. And this is going to be very important because we have this reduction in sentencing probabilities at the same time that we're increasing the hazard of execution when you're on death row. And so if prison essentially is miserable enough, this first change, this reduction in sentencing probabilities, can totally overwhelm any effect of an increase in the hazard of execution. And that's going to be pretty important. We're actually, basically, if we assume anything but being in prison is exactly the same as being out in public, if we have any difference in utilities, then this top effect totally overwhelms this. And we get basically our model can't be solved because we have a reduction in the probability of going to prison, conditional on murder, and we also have a reduction in crime rates. And so, inconsistent with our model.
You also have other crimes, right?
Yes, that's right.
Which you don't think are effective by execution, but are effective by the penalty.
That's true. That's true.
One question I have for you're sort of assuming we know a lot about the shape of this demand curve because we're in this data. But I mean, like, hardly any people eat pickled pigs.
Yeah.
Right. So you could say, well, I know a lot about what the demand curve for pickled pigs must look like.
Yeah.
Because there's only 1 in 300 people who eat meat. Why is that? I guess I don't really understand how the fact that murder is rare sort of tells me a lot about what the shape of the demand curve looks like.
Well, I think that.
Why doesn't it apply to all goods that people consume rarely?
Sorry,
I mean, there's all kinds of goods that are really rare. Hardly anybody does.
Yeah.
So why doesn't this argument that somehow I know I'm in the tail of the distribution, and the shape has to have, demand curves have to be kind of concave because the change in the quantity is going to go down real fast as you change the price? Why doesn't it apply to all rare goods? The demand for 2-carat diamonds must look like that too, because hardly anybody has 2-carat diamonds. So demand for 2-carat diamonds must be really concave, because almost nobody does it. I mean, it just seems to be an argument. I don't. And you can always say, well, the guys who buy 2-carat diamonds are like way out on the table. But maybe it's right, but it seems. I don't know how rareness sort of tells. It's like the Pecos thing. It's like I don't know how rareness tells me about the shape of it.
Yeah, this is actually this as we were doing this, I thought of the Pecos paper.
Yeah.
It's obviously not as sophisticated. It feels like we're fitting a few data points with a distributional assumption.
Yeah, exactly. I guess I'm saying more generally. This argument that somehow something's rare tells me.
With the diamond argument, I guess you sort of have an underlying income distribution, so that's one thing. But with the murders, yeah, I mean,
I just don't understand how I can go from the fact that an activity is rare to telling me, therefore, I know something about the shape of the demand. It just seems to me, maybe there's a great theory out there that tells me that, but I don't have a feel for that.
I think the other ingredient you need is that the utility has some kind of thin tail distribution, so the tails thin out. And if you believe that's true, I'm not sure it's true.
Yeah, I guess that's the question. That's the question I have. And it just seems to me there's not such a robust relationship between rareness and shape of the demand curve, which is really what we're assuming here.
But all it needs is that the tails thin out as you get near the edge. It doesn't need any particular shape or ratio, and that's.
I agree. It's because when you draw a distribution, you get a demand curve that looks like this, right? You get a demand curve that looks like that. And so you automatically kind of assume I got this concave demand curve because I'm in the low probability. I'm sort of beyond a certain point in the distribution, the demand curve becomes concave. I just don't, how well does that do empirically? If I look at the number of guys who buy Hyundais versus buy Toyota Corollas. Well, the demand for Hyundais must be concave because hardly anybody buys it. It's like, again, it's weird. It's like, I don't know why I can hold the shape of this distribution constant as I vary the fraction of people who do it. That's what seems to be. And the odd part. It's like we have this fixed distribution, and then as we go across goods, some goods are in the thick part of the distribution. Some
goods are characterized by the cutoff in some sense, not by the shape or something.
I think cars are a little more complicated because there are so many cross-price elasticities, and if you really think people are deciding between murder and violent crime, then it's a little more plausible to think there's just one random utility term that distinguishes people. Whereas if people in all different kinds of places are substituting to 100 different goods.
I just think it's more like the distribution shouldn't be invariant to the cutoff. The fractions of the distribution. It's not like we have a fixed distribution and then different goods have different cutoffs. It's like somehow those two are interrelated. Something like that. Just my gut reaction. It seems like we're getting a lot of mileage out of something we don't know much about. And that's what this is. It's like the Vegas thing.
But I feel like, because I feel like if you did have some kind of near demand, then it would. Why is it then if you have some price variation, then you wouldn't draw a lot more people into that market? Because it seems like it is linear, and then you have this big price change, but you only draw in a few people, then you're sort of like saying that, okay, there's only a small market for people that are ever potentially going to use this product, but you can say the demand is linear, so when you see these price changes, you don't see that much action, And I think
it's probably a good model for murder.
It's probably a good model for murder. Murder was free.
Pickle taste speed.
A
lot of people who aren't on the margins weren't thinking about it. So you could sort of think about, for a lot of things, you could clearly, for those kinds of things, you could move these shares around totally independently of the shape.
Then how do you justify a market that how do you justify a good that then you have to make some assumption about
people
utility?
Just negative, there's a whole bunch of people who have negative value of murder. You wouldn't murder anybody if there was no like 98% of the population has negative value for murder. So now we're talking about what's the distribution among the 2% of people who would think about murdering somebody. Now the fraction of people who are committing murder is not a low number, it's a big number among the relevant population. I guess that's what worries me about deferring too much from the shares. But that's a kind of a footnote.
In like a hunter-gatherer society, everybody commits murder. In primitive societies, murders everybody. So we can say, as we switch to being civilized,
It doesn't have to be intrinsic.
Are you
It's
feeling
not intrinsic. That's like natural.
It could be like-
People aren't murdering. I mean, in hunter-gatherer societies, it's really theft, right? Killing people is like a good way to steal their stuff.
To move on with the point that wasn't obvious to me until we thought about this for a while is that what really matters, whether it's linear, is the changing density of that utility term right around the tail. And you're saying the density changes in a different direction, and it could be, but it's useful at least to know the thing you have to think about is how does the density change around that tail, and then people would take changes on that.
There could be kind of even increasing numbers of people on the margin. That's what I'm saying. It's just hard for me to know.
So here are some differences in mortality rates between prison life and public life. These are obviously self-selected people in the prison population, so it's not especially clear if they're directly comparable. But basically, younger males get a survival advantage in prison, and this might be because they're shielded from violence or shielded from accidents. And then as they grow older, they start to die off. Now, unfortunately, we couldn't find that. We don't know the distribution of state prisoners above 55, so we had to do some weighted average of these 55, these two 10-year age groups, and we ended up deciding that 75% of prisoners at age 55 are age 55. It's a very small. It's like 6% of prisoners who are above 55. So we crunch all this together with the U.S. life tables and get some results. So the baseline, so the baseline here is sort of current numbers, and then we take some experiments, try to see what happens if we increase anything. If we increase sentencing probabilities or execution hazards 5-fold or 10-fold. So we started out with a probability of death row conditional on murder at 1%, and a 45% chance of ending up in prison, and a 2% annual hazard of being executed, conditional on being on death row. And that gets us exactly what homicide rates are today. And then we first try holding constant the hazard of execution, but increasing the sentencing probability. So if we take this tree here, right, we decide to kill or not to kill, and then they get sentenced, and then our probability is down here of dying. And so the first one, we're varying the probability on this branch of the tree. And then after that, we're going to hold this probability constant, and then move down here and change the probability, the hazard of being executed. And so what we find is that when we increase the probability of being sentenced to death row without changing the hazard of execution conditional on being on death row, it has a much bigger effect than holding constant the probability of sentencing and changing the hazard of execution. In any case, we find that we can essentially wipe out homicide by increasing either tenfold. But of course, this is all based on 2 data points in normal distribution. So,
but isn't it weird to think this? You just told us that it's safer to be, if you care about living, it's safer to be in prison than it is not to be in prison?
When you're young, yes, it's true. So for a 20-year-old, life expectancy with life in prison is lower than life expectancy out of prison. If that makes sense. Just because the survival probabilities are so different. And we're assuming here that the person lives the rest of their lives in prison, which of course is.
But if you wanted to live the equivalent life, you could hold up in your apartment, you probably have a lower death probability in prison.
That's probably
But, you know, because you go out and do stuff and you're not, I mean, it's hard to believe that that's a cost, right? There must be some offsetting.
That's where it comes. That's where these weights come in. These weights for quality of life in these two states come in.
Yeah.
And of course, in order to close the model, we have to
But
assume
you would,
that.
but you would love, but doesn't that tell you that you want to make the weights at least big enough to offset the quality of life? You'd want to make the quality of life adjustment at least big enough to offset the death rate adjustment.
That's right.
Because otherwise it would seem like I could be at least as safe just kind of like hanging out in the apartment as I could be in prison.
Are you guys going to say anything about the power of Isaac Ehrlich's regressions? Like one of the things that I've been thinking about, is you could sort of take this cat's live industry Storovich extrapolation, or take a theoretical extrapolation and say, what's a plausible magnitude of the effect of a change in the execution rate on the homicide rate? And then you could say, what are the standard errors of a regression of homicide rates on something that varies about as much as the rate of execution? Controlling for like staying year dummies or whatever it is that somebody would normally want to do. In other words, suppose somebody went out to implement some empirical strategy. Yeah. Could they ever have the power to detect an effect of a plausible magnitude? I would have thought the answer is not even close. Right? So one of the lessons I take from like this example, here we go.
Yeah. So
But it's not just this. It's just even if you have a great identification strategy, that's where you're going now.
There's just so little variation.
Right. The effects are so small relative to the scale of the variation that the likely, even if you take this cat's live industry Storovich number, which for all the reasons you said, it's got to be an overestimate of the effect of executions because it's a medium for all these other conditions. You're going to find out that there's no way Isaac Ehrlich could be right. His identifying assumptions cannot be correct.
Yeah.
Because he's finding effects that just don't make sense.
In one of the graphs he shows his sample in the time series, and it shows it's throughout the graph to series move all over the place, and there's one exact point where it goes
aside. Leave all that aside. Say, look, let's say you compare Texas to the rest of the country. Texas executes how many extra people than they would if they at the national rate?
It's not a factor of 5, isn't it?
No, but how many people?
They execute like 40 out of the 60 people.
So they execute, let's say, 40 people. Assume it's all extra. They execute 40 extra people. Your deterrent rate that somebody says, okay, let's assume one murder is saved for every guy we execute. The question is, could you see in the data 40 fewer murders in Texas? That's really the question. Would 40 fewer murders in Texas be detectable above other background choices?
But I think unconditional means goes the wrong way. Texas has more murders.
No. Assuming you had in a Texas-sized natural experiment and say, would that 40 fewer murders rise above background noise? Isn't that the question?
I would say the standard deviation of murders in Texas is probably well over 100, right?
Yeah, exactly. That's the point.
You need a lot of experiments before you could tell if your model was right. Basically, like if your model was 40, 1 for 1 for 1 or something like that. Even that model requires a lot of data, a lot of experiments.
So you have a difference world where you have a world where all executions were outlawed, and then they allowed them in Texas and everywhere else, but Texas did them. So then you got to multiply 1.44 times the thing we just did. It seems to me
if half the states executed 40 people and half the states executed 0 people, I would expect it to be.
We could pick that up.
That'd be fine, yeah.
It would be. If it's true, then you would have to be there.
Oh, what about Texas? What about just Texas? Just the experiment we had. We had a period in the 70s where there was no executions, and then we went to Texas and Florida versus the rest of the country.
I mean, you kind of know from this. If you think you got to have huge effects, because the Texas homicide rate fallen by more than 50%.
That's my point exactly. I just want to say.
So unless you think that we're talking about 15 or 20, if there were 10 homicides deterred per execution, then you could probably detect that kind of thing.
That's what I'm saying.
Which is a big number.
That's the power calculation you want to do.
Yeah, you would like a 10 time increase should be in the data.
I'm just pausing to emphasize that just because Ilya was asking the other day about data and stuff like that. And this is the kind of calculation you want to do before. If somebody says, hey, you want to spend $100,000 of your time and money putting together data on this Texas experiment, you can kind of say, well, let me figure out what do I know that gives me what would be a great result, an order of magnitude, like, one murder saved for every execution or something, and then I can go and say, well, even if that's the case, I'll never see it in these data. So I'll keep my $100,000 for something else.
But the thing you have to do is, you run the regression of like murders on time dummies and state dummies, and then we sort of say, how much state-by-state variation is there? And that tells me, because if there's huge declines in murder rates, but that's common to all the states, then you still kind of have...
You might be all right.
You might be all right.
Yeah,
so you really want to know the state idiosyncratic.
What I often do is set up the regression I'm going to run and put in like a fake right-hand side variable.
Exactly. Or put in all the other fixed effects.
Yeah, put in everything else, and then I just start. I don't want to pretend like randomized variable and just ask what's the standard error on the coefficient from that guy.
Yeah, it's like thinking what would be the first stage be, let's say, changing from legalizing capital punishment, how much would that affect? It affected taxes by 0 to 40, everybody else from 0 to 1.
Yeah.
That's not.
The year-to-year variation.
Yeah.
So do you guys have that calculation?
No.
Okay.
But
Can I make one point about this regression as continuity?
Yeah, I think I want to.
You're going to say something about that?
Yeah,
Okay.
because if you use, when you use age as a parsing variable, it's the exact case where regression discontinuity is not standard, right? If there's a huge impact, it could be just a factor that I'm going to kill I'm 19, converge 20. If I have to kill someone, I might as well do it now. So you're bundling it with
wrong parameter.
Yeah. That doesn't say anything about extending capital punishment.
Absolutely.
You're bundling with the discount rate or the myopia. You have to think everybody.
No.
Not bundling it, but
no.
If everybody's totally myopia,
first thing
you just
put aside myopia and stuff like that. That experiment isolates the intertemporal substitution in murder over time. It has nothing to do with the deterrent effect of capital punishment. Yeah. It's a totally different experiment from the effect of turning on or off capital punishment. For the reason you said initially.
No, but in the sense that if nobody cared about capital punishment at all, then for any intertemporal self-substitution, there will be no effect.
True.
That's the only thing you can see.
But you can have a huge deterrent effect of capital punishment and see no discontinuity in that.
That has nothing to do,
You can see no discontinuity in that graph.
Yeah.
Right. So you have a huge potential for false negatives there.
Yes.
Because if we impose capital punishment and as a result people don't embark on a life of crime, they're less likely to commit murders at all ages, that doesn't show up in any way as a discontinuity.
Yeah.
It just shows up as stuff you're controlling for.
You're saying if murder, it can go the other way too.
Right.
You're saying when murders, it's like we said yesterday, it's a human capital variable.
Exactly.
Then your complements,
Exactly.
and therefore you understate the effects. If it's a stock variable, then you substitute.
Then it's overstating the effects.
Well, it'd be interesting to look at a gang and see if they had all the juvenile do the murders.
Right, but that doesn't tell you the capital punishment, the deterrent effect of capital punishment. That tells you
No, but
basically how good they are at arbitraging the
Yeah,
rule.
but it would be evidence for the intertemporal substitution.
It would be a similar kind of substitution. It would be like gaming the rules like tax arbitrage or something like that. Yeah, that's a good point. It's like it's just a wrong parameter.
Yes.
Or a different, maybe not wrong, but a different parameter than effective.
It just tells them if I push it like 1 year before, then all the 18-year-olds will be doing instead of them, which is not perfectly possible.
Right. I agree. You guys even have to say that.
And then this is pretty much basically the idea of
Unless they make it worse, that's almost the definition of data.
But it's more than that.
If I back up and develop, it's the power calculation.
You need to have this power calculation.
Yeah.
All right.
All right.
Anyway, well, thank you all very much for coming. Please give us any feedback, good or bad, particularly the bad stuff.
Yeah, we'll distribute some surveys for you guys to fill out.
We want to learn what we should do differently in the future. But thank you all for coming. But please give us the things I mean, if we did something right, you could tell us that too. But most importantly, for the going forward, is to learn what we could do differently.
Thanks, guys.
Thank you, guys.